Hey folks, welcome to Bright's Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at Gauteng prelim question paper, okay, 2025. All right, paper one. So we will move as fast as possible, but with a clear context of whatever that you're going to be doing here. Okay, yes. So 1.1 says, given f of x it is equal to those factors, solve for f of x it is equal to 0, okay? If basically they're just saying to you solve for the values of x, but now there is a condition 1.1.1, if x is an integer, okay? Remember, an integer, it is nothing that it is a number that is not a fraction, that is not it's basically just a number that is clear, a clear number, okay? -2, -4, 0, 1, 2. So it's just a basic clear number, okay? So if I were to check between these factors here, let me try to simplify these factors. This one is going to be x squared is equal to plus, okay, 3. And then, so this is clear. It's going to give me something like square root of 3. So this is not a perfect number. And then this is going to give me a fraction 1 over 3. It's not a perfect number, or rather an integer. So an integer, it is this one. So x, it is equal to -2. Okay, that's an integer. And then a rational number. A rational number, it is the one that can be expressed in the form of a fraction. What do I mean? 1 over, but now its fraction should now be a terminating fraction. What do I mean by that? It is a fraction like 1 over 2, it is 0.5, and then it ends there. Okay, or something like 1 over 3. 1 over 3, it is a continuous. Can you see it is continuous like that? So this is how we refer to a rational number. But also we still also have, let's say maybe 7 over 1, which is equal to 7. So this number can be expressed as also as a fraction. So it can be expressed as 7 divided by 1. So it also qualifies as a what? As a rational number. So if I were to check of my options there, I see this one here. It's going to be 3x, it is equal to 1, and then x is going to be equal to 1/3. So x needs to be 1/3, or x needs to be -2. Remember, -2 is the same as -2 divided by 1. So hence now it also qualifies to be what? A rational number. And real numbers, 1.1.3x is a real number. A real number is anything on the number line. Okay, is anything on the number line. Remember, this one can be solved. Okay, this one, it is x squared minus 3, it is equal to 0. X squared, it is equal to 3. And then x, it is equal to, remember, everything that you square should be plus or minus, okay, when you take a square. So our answers are going to be x, it is equal to plus or minus square root of 3. And then x, it is equal to 1 over 3. Real numbers are all numbers, basically, except for complex numbers, which you are not exposed to. Okay. 1.2, this was a nice different structure of came by those who were setting the paper of everything. 1.2.1, okay, we are solving for x. We have this one correct to 2 decimal places, so I automatically know I need to use my quadratic formula here. Let me zoom on to a specific question we are looking at. Then the formula says, I won't write the formula because we all know it. So it's negative b is -9 plus or minus b squared minus 4a, it is -15. And then my seed is +4. Okay. All that should be divided by 2a. All that should be divided by 2a. And then I get x to be, sorry, to be -0.90, or x to be something like 0.30. So yeah, remember we mark this 1 mark for formula, 1 mark for 1 mark for substitution, and both answers correct like that. Okay, and then let's move on. Sorry, to 1.2.2. 3x minus 2 squared is greater or equal to 3x. So I want to believe this is one type of question, yeah, quadratic inequalities. So let's try to simplify this. So when I simplify this part, I square the first term. Remember, this is the same as 3x minus 2, 3x minus 2. So you can do that, but I know I square the first term, and then the product of the two, 3x multiplied by -2 multiplied by 2, so it's -12x. And then I square the last term, negative 2 squared, it is positive 4. And then I take the 3x to the other side, then greater or equal to 0. And then I try to simplify my beautiful mathematics. Minus 15x plus 4 is greater or equal to 0. Now let me see factors of 9 times 4, it is 36. Okay, factors of 36 such that when I add them, I get negative 15, 9 and 4. Okay, 12 and 3. Yes, 12 and 3. 12 and 3. And then I'm going to divide by, okay, both of them should be negative. Divide by 9, divide by 9. So I have 3x minus 4. And then I also have 3x minus 1 as a factor greater or equal to 0. And then the critical values, by the way, the critical values are, let me see, this is 4 divided by 3. And then 1 divided by 3. So I have the smaller one, which is 1 divided by 3, this one, when I equate to 0. And then the other one, it is 4 divided by 3. How do I find this critical value? So I just say 3x minus 4, it is equal to 0. Then x, it is equal to 4 to the other side divided by 3. So it's basically that. And then we know the standard typical way in which we do this. Okay. This is a parabola here. Can you see that? Okay, let me put 1 over 3 first and 4 over 3 here. This is a standard parabola. Why? Because can you see 9x squared plus what the of standard form. Then the value of a is positive. Here it is positive, so it is a smiling parabola like that. And we want where this is greater or equal to 0. Greater means above. Where is our function defined above this portion and that portion? So it means therefore our answer should be x should be, it's going to that side. So it should be less or equal to 1/3, or x, this one goes to that side, should be greater or equal to what? To 1 over 3. Okay, some may use it like this, say, find a number between, this is 0.33, by the way, this is 1.33, I think. I'm just approximating, sorry, the English mathematics. So I just put 1 and see a number between these two, which is 1. Let's put 1 here and see it's going to give us what? When I put 1, it's going to be 3 minus 4, and 3 minus 4, it is negative. And then when I put 1 here, it's going to be 3 minus 1, which is positive. So negative by positive is negative. So if it's negative here, it means the other ones are going to be adjacent like that. So hence we want the way it is positive. Remember, greater than 0 means positive. Okay, hope it's clear. Then let's move to this one. I see the use of what is exponents here. I have 5 to the power of x. Let me try to simplify. This is 20. 5 times 4 is 20, plus 5 multiplied by 5 to the power of 2 minus x. This, without simplifying it, let me just put it as 5 multiplied by 5 to the power of 2x. So 2 minus x. And then, remember, what does the laws of exponents say to you? They say if you're having ax plus b, you can express it as a to the power of x multiplied by a to the power of b. Okay, so let me say 5 multiplied by what? 5 to the power of 2 multiplied by 5 to the power of negative x. Okay, but remember, if I have a to the power of negative 1, it can be the same as 1 divided by a, or let me use a to the power of negative x can be expressed as 1 divided by a to the power of positive exponent. So I'm still having 5x, it is equal to, sorry guys, this is plus 20 plus 5 multiplied by 5 to the power of 2. And then let me take this to the denominator, because remember, this is just one term, okay? So I'm going to just divide by 5 to the power of x. Why am I doing this? Because I want everything to be in a positive exponent. But now, if this is the case, it means I need now to multiply by what? By 5 to the power of x, so as to remove this part. So if I multiply everything, okay, when I multiply everything by 5 to the power of x, okay, let me do this. Multiply everything by 5 to the power of x. So it's going to give me, this one is going to be 5 to the power of x multiplied by 5 to the power of x. Remember, when I have a to the power of x multiplied by a to the power of x, it's going to be a to the power of x plus x, which is a to the power of 2x. So when I'm multiplying this and it has the same thing, so it's going to be 5 to the power of 2x. It is equal to 20 multiplied by 5. It's going to be 20 multiplied by 5 to the power of x. And then plus 5 times 25, it is 125. This one is going to cancel. Okay? This one is going to cancel with that one. And then 5 multiplied by 25, it's 125. Then I see something in the format of a quadratic, something squared. Let me put it like this. Okay, another property we need to know is that if I have a to the power of 2x can be expressed the same as a to the power of x all squared, or a to the power of 2 to the power of x, a squared to the power of x. So, but the format that I wanted is this one. So I'm going to say this is 5 to the power of x all squared. Then take this to the other side, 20 multiplied by 5 to the power of x, then minus 125, it is equal to 0. Now I want you to see it is something squared minus 20, blah, blah, that's something minus 25. So if you can just take this as x, just take to the power 5 to the power of x, xk maybe. It's going to be k squared minus 20k minus 225. So can you see this is a typical quadratic thingy? So what's important is that find factors of 125 such that when you subtract them, they give you 20. Okay, actually for simplicity, remember we are here to simplify everything. Let 5 to the power of x be equal to, actually let k or any letter that you like be 5 to the power of x. If that's the case, we have what? K squared minus 20k minus 125, it is equal to 0. And then when I simplify this, k minus 25 and 5, okay? So it's going to be minus 25, k plus 5. You can use quadratic formula, however that you want to use. And then I'm going to have k is equal to 25, or k is equal to negative 5. And then let me substitute back what is k. K is 5 to the power of x, it is equal to 25. It is 5 to the power of 2, or 5 to the power of x, it is equal to negative 5. Then here I know x, it is equal to 2, or this one has no solution. Why? Because 5 to the power of x is always greater than 0. What do I mean? 5 to the power of x, it is an exponential function, by the way. Okay, it is an exponential function that looks like this with an increasing thing. So the value of y can never be negative. So remember, this is x, this is the y. Can you see that y values start from negative, from 0 here, where x is equal to 0, all the way to infinity. The values of y start here all the way to infinity. So, and we know that it has a range. A range is y is always greater than 0. So hence now, when we see that it is negative, it can never happen. Okay, anything raised to the power of x will never be negative. So 5 to the power of x is always greater than 0. Therefore, you're gonna say no solution for this one. Okay, because it does not happen that we have 5 to the power of x being negative. Okay, I'm ready to move on. Solve for x and y. This is just standard simultaneous equations. So let's look at this one. Log x 16, log base, log x base 16 is equal to 14. So normally I tell my student that if you have y is equal to a to the power of x, now when you just change it to log, you're gonna say y it is just log, and then everything here you just put it as it is, a to the power of x. So this is how you change from exponential to log graph. You just introduce log. Just put log and then a to the power of x, it remains the same. So when I want to go back and reverse this process, it means I'm going to just say a to the power of x is equal to what? Y. Okay? A to the power of x, it is equal to y. Or rather, okay, let me do this. Let me say I want to solve for, so that it becomes simple. I want to solve for x. So when I want to solve for x, it's going to be x, it is equal to, okay, let's say it is solve for x. X is going to be equal to, when I drop this x, like that. I should drop it legally. So I introduce log, and then the y and the x change the exponent. They change their position. So it's gonna be a remains the a, and then y will remain as it is, like that. If I'm solving for a particular variable, let's say I'm solving for x. Okay. Yes. So in this case now, we are having log x 16 is equal to 4. So when I want to change this and let this x become the x, remember the x will always be the base, okay? Will always be the base. So now remember I said if you want to move from y is equal to a to the power of x, and then when you're solving for x, okay, for x, you just say x, it is equal to, you drop x, and then you introduce log, and then a to the power of y. So similarly here, when I want to solve for x, it's going to be x, but now when I need to remove this log, so this and this will just swap the position. Every time when you introduce log, these two swap positions. When you drop log, they also swap positions, okay? So this will be the same as x is equal to, I drop the log, then these two swap the position. When these two swap the position, x to the power of 16 will no longer be x to the power, I'm calling it wrongly x to the power of 16. It's not necessarily x to the power of 16, but it is log 16 base, log x base 16, or log 16 base x, whatever. So it's going to be 16 will now be 4, and then 16 will go to the other side like this. Okay, I hope it makes sense. And then I'll have, well, I can take the fourth root. When I take the fourth root, x, it is equal to, well, I think x is going to be equal to plus or minus, but let's say it's 2. Okay, and then let me just say this is equation. Okay, by the way, this is equation 1. This is equation 2. I just created equation 3 here. So let's substitute equation 3 into equation 2. Remember what you just simplified. You need to be substituted in a formula that is not simplified yet. So I'm going to say y is equal to square, and not y is equal to, so about that. Where I see x, I put 2 plus 7. Okay, and then it is equal to, where I see x, I put 2 plus 1. And then they are telling me that where x is greater or equal to 0. Okay, so that condition you should be met. And then let's see what we have here. What we have is y, it is equal to square, sorry, y plus square root of 9, it is equal to 3. And then let me isolate the square root. When I isolate the square root, I can say y minus 3, it is equal to negative square root of 9. Or if you are scared to put a negative square root of 9, not square root of negative 9, negative square root of 9, I'm going to just leave square root of 9 here and then take the y to the other side. So I'm going to square both sides. Square both sides. So this will be 9. It is equal to, I square the first term, the product of the two multiplied by the exponent. And then I can put this in a standard way, y squared minus 6y. And then when I take the 9 to the other side, it will just be 0. And then 0, it is equal to y into y minus 6. And then y will be equal to 0, or y will be equal to 6. Okay, so yes, that's that. That's that. But now we need to check. Remember, every time when we have square root of something, blah, 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 we need to check if they satisfy the condition. Because can you see, we only have one value of x. So I want to believe there should be one value of y. Let's check. If I come to this portion here and check when y is equal to 0, let's see, we have y plus, okay, 0 plus square root of 9 is equal to 3, and then this is 3, it is equal to 3. So this is a solution, it's fine. And then let's check when y is equal to 6. We are going to have, when y is equal to 6, I'm going to have y plus square root of 9, it is equal to 3. Well, y is 6, and then this is 6 plus 3, it is equal to 3, and then 9 is not equal to 3. So y is equal to 6 is not a what? Is not a solution in this particular case, they're off. Every time when you square something like this part, remember normally this question it appears on 1.5. So every time when you square something, you need to confirm your answer, the off. So you need to now indicate that this is what? This is only the only answer that we have. It is what is this? The only answer that you have it is that actually I did not even need to go here. I don't know why I'm playing so I'm playing smart here. I could have came here, by the way. Some things are just basic and you like to complicate them. Y plus 3, it is equal to 3. Square root of 9, it is 3. And then y is equal to 3 minus 3, it is just 0. Sorry, guys. I'm supposed to make your life easy, but I'm making it difficult. Sorry. Let's move on to 1.4. Calculate two numerical values for P so that this part here is a perfect square. Remember, when I have a perfect square, the discriminant should, so not then delta x, I'm doing physical science now. Remember, for perfect square, okay, the discriminant should be equal to 0. Okay, yes, the condition for equal roots, basically. Okay, or what you can do, you can complete the square. You can complete the square, but that will be a long process to take the off. So let's try to simplify this part. Okay, let's simplify this part a little bit. So I'm gonna have, sorry, x squared plus 2xp, let me say 2px plus 7p plus 8. And then I'm gonna say, okay, the discriminant, I know the discriminant need to be greater than 0. And what is my discriminant, by the way? Remember, my discriminant, it is b squared minus 4ac. Needs to be greater than 0. So b, remember, okay, everything that has x, let me do this. This is my a, x squared, bx, and this is my c. So when I have ax squared plus bx plus c, so this one matches the what? The x squared. This one matches the what? Something that has x. And then this one matches everything that is left, which is 7p plus 8. So b, in this case, it is not x, but rather p, 2p. For a, how much is a? 8 is 1. C, it is 7p plus 8. This needs to be equal to 0. And then this is going to be 4p squared minus 4 times 1 times 7, it is 28p, minus 4 times 7, 4 times 1 times 8, it is 32, if I'm not mistaken. There. And then this needs to be equal to 0. And then when I look at my factors, actually I can simplify this. I think I can divide by 4. So when I divide everything by 4, I'm going to have p squared minus 28, 7p minus 16, 32 minus 4, 8. That is equal to 0. And then I have p minus 8, p plus 1, it is equal to 0. And then p is either equal to 8 or p is equal to negative 1. So those are now the factors thereof. Beautiful stuff. Let's move on to question 2, which is now number patterns. The following sequence of number forms a quadratic number pattern. Okay, so we are told that it forms a quadratic number pattern thereof. Okay, and then what do we know about the number pattern? It has the first difference, which is not constant. The first difference forms the linear equation, and then the second difference is the one that is constant. So 2.1 says to us, the first difference of the given sequence also form a sequence. That is true. Remember, when you have a quadratic formula, the first difference form a what? A linear pattern, and then the second difference is the one that is constant. Determine an expression for the nth. Okay? Determine the expression for the nth term of the first difference. So let's find the difference of the general formula of the first difference. The first difference are going to be negative 2 minus 3 is going to be 1. Okay, I'm forming a general formula for the first term. Okay, let me indicate first term difference. So that people are not confused. First term difference, I'm going to say -2 minus -3, which is -2 plus 3, which is 1. And then -3 minus -2, which is -3 plus 2, it is -1. And then -6 minus -3, it is -6 plus 3, which is -3. And then when you continue, it is -5, and then up to where you end. Okay. And then how do I form now an expression for that? So I already know that the value of A, it is equal to 1, and the value of the difference. What is the difference here? The difference, -1 minus 1, it is -2. So -3 minus -1, it is -2, Leon. So the difference here is -2. So you can use your typical TA is equal to A plus N, something like A plus N minus 1, the difference. And then A, it is 1 plus N minus 1, the difference. And then you become a mathematician, 1 plus, this will be N multiplied by -2, -2N minus -1 multiplied by -2, +2. And then this will just be -2N plus 3. So yeah, that's that. Okay. And then they say calculate the first difference between the 35th and the 30. Okay, so calculate the first difference between the 35th and the 36th term of the quadratic number pattern. So they want you to calculate the difference. Okay, the first difference between term number 35 and term number 36 of the quadratic pattern. Okay, so what I normally tell my students is that when you have a quadratic pattern in a, okay, quadratic pattern like this is a quadratic pattern. This will form a linear pattern. Okay. What I normally tell them is that the difference between T2 minus T1, the T2 minus T1 of a quadratic pattern forms T1. So T2 minus T1 forms T1. And then T3 minus T2 forms T2. So whatever the difference between the numbers, let's say Tn minus Tn minus 1, it forms the one that is less. So the one that is less between the T2 minus T1, the difference, it is what? It is that. So it's going to form T3, T4. So it means the difference now, if I were to make sense of this, okay? If I were to make sense of this, it means now the difference between T35 and T36 of a quadratic number pattern is going to form me T35 of the what? Of the linear pattern. So basically they're saying calculate the first difference between these numbers. So I need to know how much is T35. They want the what? The difference, the value. Okay? The difference between these values. So since when I know the linear pattern, I can say, let me substitute T35. It's going to be, remember the formula I have here. It's going to be -2 into 35 plus 3. And then this will give me -70 plus 3, which is -67. So this is that. Okay, I hope it makes sense. Determine an expression for the nth term of the quadratic sequence. So let's output our quadratic sequence. Remember, it is -3, -2, -3, -6, -11, and then all the way. And then the first difference we just found, I'm going to just repeat that it was 1, -1, -3, -5, and then let's find the second difference, the second constant difference. -1 minus 1, it is -2, and then it's going to be -2, -2. Okay, and we know that the first term that we are looking for, we're going to say 2a, it is equal to -2. Remember, this is 2a, 3a plus b, and then here we have a plus b plus c. Okay, so 2/8 is equal to -2, then 8 is equal to -1. Okay, and then 3a plus b, it is equal to 1 there, and 3a, it is -1 plus b, it is equal to 1, and then b is going to be 3 multiplied by -1, it is -3, -3 to the other side is going to be 4. Okay, and then a plus b plus c, it is equal to the first term of the quad, it is -3, and then I have a to be -1 plus 4 plus c, it is equal to -3, and then the value of c will just beautifully be how much? It will just be -6. It will just be -6. So the general term, it is Tn, it is equal to -n squared plus 4n plus, not plus, rather, -6. So that's that. And now I like students to confirm if their pattern is correct. By how? How so? How so? Just again, you know, this is term number 1, number 2, number 3, number 4. Just insert 4 here and as find T4. Basically, just try to find T4. Let's check. Let's check T4 already is equal to the term that is in the pattern now. Okay. So this is -16 plus 16 minus, sorry, not -16, -6, -6. So this is, therefore, this gives me T4 is equal to -6. Is T4 equal to -6? Indeed. T4 is equal to -6. So this is just you confirming your answer. It's not important for the examiner to see. It's important for you to prove that your answers are correct. Then 2.4, they say, explain why the sequence will never contain a positive term. Okay, the sequence that we are having, this one, we are having, why? We need to prove that it will never have a positive number. So can you see that our sequence, it is -3, -2, and after -2, it repeats -3. So I want to believe our function is something like, since when it has a pattern of -n squared plus 4n plus -6, remember this is a quadratic pattern or a parabola with a set face like this. So it means my parabola, it was like this, okay? I know it means my parabola is like this, okay? And I know for my parabola, the values, they correspond here, okay? The values correspond there until we reach the maximum value. So it can happen that we started calculating here. Let's say we started calculating here, or the pattern was recorded from here, -3, -2, and then can you see it repeat -3 because the values should correspond there because it is symmetrical like that. So, by the way, we are talking about the values of y here. These are the values of y that you're talking about. Then it went to be -6, and then -11, negative blah blah blah. So it means even in this case it was going to form that sequence thereof. So what you need to do is, okay, let me illustrate. You need to say, okay, let me illustrate this in a form of a parabola, maybe, so that it becomes, it's very acceptable, guys, to reason using a parabola. Okay, let's first find the turning point. Okay, let's first find the turning point. How do you find the turning point of a parabola? Remember, you need the n coordinate, the x coordinate. So the x coordinate is going to be n, it is equal to -b divided by 2a, or you can use the derivative. First derivative is equal to 0. So it's going to be -4 divided by 2 into -1, which it is equal to 2. And then let's find the maximum value. Okay, this is n, and then let us find the maximum value. The maximum value of the graph is, I substitute now to my original formula Tn to find the maximum value. I'm going to say negative into, okay, this value of n, it is when my x, basically this is the same as the x value again. And then when I'm calculating, it is the y value. This is the x value at the maximum point. Let's say x value at turning point. And then what I'm calculating, it is the y value at the turning point. If I can show that the y value of the turning point is not positive, then all the numbers that are going to follow will never be positive. So negative 2 squared plus 4 into 2 minus 6. This is negative 4 plus 8, which is negative 4 minus 6, it is negative 10. Negative 10 plus 8, it is negative 2. So if my turning point has the coordinates of 2 and negative 2, can you see now that it forms something like this? It means I have a parabola of some sort. A parabola of some sort that is facing downwards. And then the maximum value it can reach, it is 2 and negative 2. But mostly important, focusing on the y value. So can you see if the maximum y value here, it is equal to negative 2, then it means whatever the values that are below are going to just be negative, because this is just the maximum value being how much? Negative 2. So this is another way you can prove that this can never have a positive root. Okay, so what I think you can get the marks for, since well it is 2 marks, it is showing that we have a maximum value at, or rather calculating the turning point, and then explanation of now there are no values that will be now above. Okay. Okay, however you can explain that, or you can complete the square. And then you'll see when you complete the square you should have something like so this is your maximum value. So already you see that your maximum value, okay, your maximum value, it is equal to negative 2. Therefore, no positive terms are going to be there. Okay. Okay, this is when you do completing the square. Cool, let's move on. Question 3. The graphic below shows a dartboard from which pattern relevant to the different circles can be derived. Okay, so we have this particular thing thereof that they call beautifully to be whatever dartboard. So it has circles, okay? So each and every circle here has a different diameter. Okay, or rather, let me talk of radius. It has a different radius relative to the this one. So this one is a radius like that. This one is a radius like this. This one is a radius like that. So the radius, can you see that it increases as we move towards the outer? Okay, so they have different what? Radii. Okay, so it's basically like that. They have different radius, by the way. So I think they're going to tell us. So the radii of the largest circle, okay, so the radii of the largest circle and then moving consecutively to immediate inward circle is given by, okay, let's digest this English. They're saying now the radius of the largest circle, which is this one, okay, going inwards like that, respectively or consecutively, okay, successively in that order, okay, it is. So remember, as we go inwards, the radius decrease. So they are telling us it is given by what? It is given by that quadratic pattern thereof. It is given by, so not quadratic pattern, by this linear thingy thereof. So it means now we see that our radius are forming as a what? Our radius are forming as a what? What is this? Our radius are forming as a pattern thereof, okay? So it forms as a pattern 18 centimeters. That's the first radii. The second radius, that's the first radius rather. The second radius, it is this. The third radius is that. Then going on inwards, and you can see that the radius decreases. And then they say the innermost circle has a radius of 2/3. So the innermost radius has the radius of 2/3. So this is the last circle. Okay, this is the last radius of the last circle. This is the radius of the last circle. Yo. And then let's move on to questions 3.1.1. Show that the area of the circle form a converging geometric sequence. Now what? Show that the areas, okay, the areas of the circles, okay, form a converging geometric series sequence. Now let's consider this one. Remember, we have 18 centimeter, and then, but this way, this is just the radius, okay, 6 centimeter, all the way to the inner radius, which is 2/3 centimeter. So now, if I can prove that the radius, okay, the area from, I need to find the areas, okay, and then see if the area, remember, if something converges, okay, the value of r should be between -1 and 1. So if I can find the area and then prove that the r that I find in those areas is rather indeed between -1 and 1, then that will be fine. So remember, what is the formula for a circle, area of a circle? Okay, area of a circle, it is given by uh, pi r squared. So now let's try substitute the pi r squared multiply. So substitute 18 so that we form a formula of area. Okay, let me say area sequence. So when I substitute 18 squared is going to be 324 pi. Just leave it as pi. And then the second one is going to be when I substitute 6 square root of 3, and then squared is going to be 36 multiplied by 308 pi. 6 squared, it is just 36 pi. All the way, when I substitute 2/3, it's going to be 4 divided by 9 pi. I don't actually need that. So let me see the value of r, okay? The value of r. Remember, the value of r is going to be T2 divided by T1, which is still the same as T3 divided by T1. So the value of r, in this case, it is 108 pi divided by 324 pi. So this gives me 1/3. And then let me try to see again if I use T3 divided by T2, if it is consistent now. 36 pi divided by 108 pi. And indeed, it does give me 1/3. So the constant ratio, it is how much? 1/3. And then I'm going to say the sequence converges. Why? Why? Because r is between -1 and 1, just like that. Well, you should be careful. They said show that the areas, if you use this sequence, then you will get 1 mark or 0. If you use the radius to prove that this is a conversion, then you'll get 0. I want to believe you'll get 0. Then they say calculate the number of circles in the sequence of the board. Remember, we have their respective radius. So remember the radius of the first one, the radius of the second one, the radius of the third one, and then we all the way we have the radius of the last one in a circle. So I know already this. Remember, the last term, it is always Tn. Okay, the last term, it is Tn. So this is my Tn. So if I can find now the what? Let us find the ratio. Okay, so the ratio is gonna be 6√3 divided by 18, which is square root of 3 divided by 3. Okay. Okay, so yeah, if you use your calculator, it's gonna give you, remember, this is the same as square root of 3 divided by square root of 3 multiplied by square root of 3. So it might give you something like 1 over square root of 3. So whichever that you use, okay? So I think we're gonna use this one. Let's use r as 1 over 3. 1 over square root of 3 rather, simplified. And then let's find Tn, okay? So if r, so we see that this forms as a geometric, okay? So arn minus 1, and then Tn, it is equal to Actually, let's just substitute. We already know what is Tn. Remember, I said the last term rather it is Tn. And then A, it is how much? A, it is 18. And then how much is R? R, it is 1 divided by square root of 3. Guys, even if you can use square root of 3 divided by 3, but I want to believe you'll be using a calculator, so it will give you 1/3. 1 over square root of 3, rather. N minus 1. So I'm trying to find the number of circles that I have. So, okay. Or rather, the number of radius that I have. Okay, the radius that I have refers to the number of circles that I have. Okay, then I divide by 18 by 18. I have multiply by 1 over 18. This is 9. So this is 1 divided by 27. It is equal to 1 divided by square root of 3 n minus 1. Stop being a mathematician and use now your logs. Okay, remember I'm trying to solve for n minus 1. Okay, let me say let me show two methods, okay? Two methods. The first one, you can say, let me express this in terms of 3, okay? So it's going to be, this can be expressed as 1 over 3 all raised to the power of 27, 3 to the power of 3, okay? And then this can be expressed as uh, 1 over 3 to the power of half. Okay, so I can say 1 over 3. Remember, this is 1 over 3, basically. Okay, let me do it like this. 1 divided by 3 cubed. 1 divided by, when I remove the square root, it is just half. And then take the 3 to the top. And then take this to the top. And then I'm going to have -3. The base are the same again. And then this I'm just simplifying at the same time. Negative half multiplied by n, it is just -1 over 2n, and then plus negative half multiplied is just half, and then you'll become a mathematician there and solve. When you solve, when I take this to the other side, or rather, let me multiply everything by 2. When I multiply everything by 2, it's going to be -6. It is equal to -n plus 1. And then n, when I take it to the other side, it's going to be n is equal to 7. Or I can say, I want to solve for n minus 1, so I'm going to drop n minus 1. But when I drop it like that, I need to introduce log. And then the base will remain as the base. And then the exponent will now, or rather, this will now be 1 over 27. Okay, remember, as I explained in question 1, that they change the position the minute I introduce log. And then n minus 1 is equal to, when you put this in your calculator, it's going to give you 6. And then n it is equal to 7. So there are 7 circles. Okay, yes. And then 3.2 says now, given the series, this 1 times 2 plus 5 times that, all the way to this part. They say write the series in sigma notation. And then inside the bracket, there is a caution that it is not necessarily to calculate the value of the series. Very, very important. Now let's try to see if it forms as a pattern. 1 times 2, it is 2. 5 times this, it is 30. 9 times this is 90. 13 times 14, it's 130 plus 2652, which is 182. Does it form as a pattern? Let's see. Linear pattern. This 30 minus this, it is 28. 90 minus this, it is 60. Linear pattern, no. Quadratic. 30 divided by 2, it is 15. 90 divided by 30, it is 3. Okay. Not also a what? Now let's think. I see Mara here they multiply. Okay, it is 1 multiplied by something plus 5 multiplied by 6. So how about I consider the first terms? Okay, the first terms. Okay, let me consider the first terms of the bracket. When I consider the first terms, I have 1. Okay, this is a series. 1. Okay, let me use a sequence 5, 9, 13, all the way to 81. So let me see, does it form me a linear pattern? Maybe. 5 minus 1, it is 4. 9 minus 5, it is 4. 13 minus 9, it is 4. Okay, this is a linear pattern. So I can say, okay, the value of A is 1, and then it has the difference of how much? It has the difference of 4. Okay, and then let me find the Tn for that. Remember, guys, on sigma, by the way, it is n. Okay, let me say n is equal to something, and then whatever value here, and then Tn. So let me find the Tn of the first terms. Tn is going to be a plus d minus a plus n minus 1d. But what I'm going to do, I'm going to say the difference, it is 4. So it is 4n. And then first term minus the difference, which is our c. 1 minus 4, it is minus 3. Okay, you can use Tn is equal to a plus n minus 1 d. And then you'll get this. Okay. And then let's look at the second term. Okay, second factors or second terms. Okay. Okay, factors. Let me call factors of the bracket. Okay. Let's see what's happening there. I have the remainders. Again, I have 2. I have, oh, and okay, before I continue, I need to know the number of terms that they have. Remember sigma, and it is equal to 1, and then m, where this is my last term. So I need to know where this is the number of terms, basically. Number of terms. So I need to know the number of terms that I have. So if the last term is 81, remember I said the last term is always 81. Okay, let's find the number of terms. Okay, the number of terms is going to be 81. It is equal to 4n minus 3. The last term, okay, it is 81. And then when I do mathematics, 81 plus 3 is 84. 84 divided by 4, n it is equal to 21. Okay, so I have 21 terms. Very important part. I have my Tn. I have my n terms. Okay, cool. And then let me go to the second factor. I have 2, 6, 10, 14, all the way to how much? To 82. And then I'll say, okay, let me see here. It forms me what? 6 minus 2, it is 4. 10 minus 6, it is 4. Okay, it's 4. So A, which is my first term here, it is 2. And then I have the difference, which is 4. And then my Tn is going to be, the difference, it is 4n. And then first term minus the difference, it is negative 2. Okay, like that. And then again, use Tn, it is equal to a plus n minus 1d. And then let me find the number of terms. Okay. The number of terms, I have 82, which is my last term here. It is equal to 4n minus 2. And then when I take, it's going to be 84 again. Okay. So n it is equal to 21 again. Okay. So they have equal numbers, I believe. Okay. Now I want to show you something. Remember, normally when we have just a pattern, okay, a pattern, let's say 4, okay, let me say 1, 2, 3, 4, 5. When we have sigma, we say sigma is equal to n is equal to 1, and then the number of terms, let's say they end to 50. The number of terms that I have, it is 50, and then my general formula is what? This is Tn needs to be here. The general formula needs to be it's going to be Tn is equal to the difference, it is 1. Okay, so it's going to be n, and then 1 minus, it's just going to be n. Okay, so it is n, just like that. But in this case, we are having two things inside the bracket. So it's going to be the Tn of the first one multiplied by the Tn of the second one. Okay, plus Tn of this. Basically, it's going to be like this. Tn1 multiplied by the Tn of the second thing is. Why? So that when you substitute 1 into the first Tn, it will give you the first term. And then when you multiply by when you substitute 1 into the second one, it gives you this number. And then when you form a sequence, the of plus, blah, 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 blah. So in this case, we will form our sigma that have something like this. We'll say, okay. Therefore, our sigma thereof, okay, I want to draw it largely. The number of terms that we have, it is 21 for both of them. So this is the number of terms that we have. And then always we like to start from n, it is equal to 1. Do not complicate it. And then instead of our Tn, we're going to substitute what? Remember, our Tn, it is something multiplied by something. So something, it is the Tn of the first difference. The Tn of the first difference, it is what? 4n minus 3. So I'm going to have 4n minus 3. Okay, remember multiply, I can represent it by 2 brackets, or I can add another bracket like this. And then I multiply by the other one. The other one has a this for n minus 2. And then I'm done. And then I'm done. Or you can simplify further and say, okay, let me make my sigma to be simple. Okay, let me make my sigma to be simple. And it is equal to 1, and then 21. And then simplify this. When you simplify that, you'll get that we have 16n squared minus 20n plus 6. But more appropriately, you can leave it here. Okay. Because now this will make even sense that, okay, it is the first term multiplied by the second one. Let's try to prove. Let's find there. Let's see if we are testing using the fourth one, T4. Okay. Let's test using T4. Check T4. Okay. T4 in the sequence will be, okay, will be 4 multiplied by 4. So it's going to be, I'm going to substitute where I see n, I'm substituting 4. So 4 multiplied by 4, it is 12. I'm lying. 4 multiplied by 4, it is 16. 16 minus 3, it is 13. And then multiply by 4 multiplied by 4, it is 16. 16 minus 2, it is 14. Let's see if I have 13 multiplied by 14. In actual fact, I have 13 multiplied by 14, so it's beautiful. So I hope we make sense of that. 3.3, in the series a plus ar squared plus blah, 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 the sum to infinity is 1. Okay, so we have a plus ar squared plus, okay, by the way, this is a geometric sequence, all the way to whatever. It is equal to 1. Okay, so this is equal to 1. And then they tell us that in the series where the terms are the squares of the above series, the sum to infinity is this. So in a series where the terms are the square of the above, so let's square. A squared plus a squared r squared, we are going to square everything. A squared r to the power 4 plus blah, 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 blah. Then now we are not squaring 1. They tell us the sum to infinity to that it is 5 over 4. Okay, so now how can we try to simplify this? Unfortunately, I cannot say use simultaneous now. What I'm going to do, I'm going to say, okay, let me find the sum to infinity of the first equation, okay? Let me find the sum to infinity of the first equation. Remember the sum to infinity is going to be what? Remember the formula for sum to infinity is a 1 minus r. So a is what? Okay, a is a in this case, the first term, 1 minus the r here. Can you see? AR divided by A, it is just R. So this one, it is just that. And okay, we get that. And we also know the sum to infinity is equal to 1. So I can just say it is 1 here. Okay. Or let me say sum to infinity. And then it is equal to 1. And then simplify this. A is going to be equal to, when I multiply these 2 to the other side, it's going to be 1 multiplied by 1. It is 1 minus R. Let's say this is equation number 1. Okay, let's say this is equation number 1. And then let's use sum to infinity for the second one. So the sum to infinity of the second one, the first term, it is a squared. 1 minus the r, it is a squared, r squared divided by a squared, it's just r squared. And it is all equal to what? 5 divided by 4. Or not 4, it is 6 rather, sorry. 5 divided by 6, sorry. Sorry about that. I know it is frustrating when you spot an error and then I fail to spot it quickly. Okay, then let's do mathematics. This can be 6 multiplied by this, it is 6a squared, it is equal to 5 minus 5r squared. Let's say this is equation number 2. And then let's substitute sub equation 1 into equation 2. And then what I'm going to have where I see A, I'm going to substitute with 1 minus r, and then all squared it is equal to 5 minus 5r squared. Were we given any condition? Okay, we are supposed to determine the common ratio, by the way, r. Okay, and remember, for sum to infinity, the value of r, your series should converge. So this is very important. For sum to infinity, your series should converge. Okay, so let's try to become mathematicians. 1 minus 2r plus r squared, it is equal to 5 minus 5r squared. Then I'm going to have 6 minus 12r plus 6r squared is equal to 5 minus 5r squared. Let's apply zero factor. When I take the 5 to the other side, it's going to be 6r plus 5, which is 11 r squared, and then minus 12r, and then 6 minus 1, it is 1, but a positive 1, equal to 0. And then when you look at the factors thereof, you can use a quadratic formula. It's going to be 11r minus 1 and r minus 1, it is equal to 0. And then r is going to be equal to 1 divided by 11, or r is going to be equal to 1. But since the series converges, r should be between -1 and 1. How do I know it converges? Remember, when something converges, then its sum is going to be equal to, we have sum to infinity, okay? So, therefore, I need to say, therefore, r is only 1 divided by 11. And then r is not equal to 1. So I need to be very, very specific on that particular case thereof. Okay, not that difficult, not that bad. Let's move. That was all for question 3. I think it was a beautiful one. Just needed you to know your applications thereof. Okay, question 4, the graph of a function, that one, and this one. So this is a parabola. Sorry about that, a hyperbola and a straight line. And then, so we have that, blah, 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 blah. Okay, now let's talk the asymptotes. We have the first asymptote, the vertical asymptote, as well as the horizontal asymptote. So the asymptotes, we're going to have x, it is equal to -2. This is my asymptote. And then y, it is equal to -1. These are my asymptotes. Equation of my asymptotes. Okay? Equation of asymptotes. And then what do we remember? We remember that if x, it is negative on the graph, when it goes to the equation, it's going to be p, it is equal to, when it is negative on the graph, it's going to be positive on the equation. Okay, and then q, which is just always equal to y, is going to be this. So this is us interpreting. Okay, so this point here, we know this point to be x, it is -2, y, it is -1. Because the x, it is -2, the y, it is -1. Let's look at the question that are following thereof. Write down the value of p and q. Very easy. P, it is equal to, we check the asymptote that we have. The asymptote, it is negative. X is equal to -2. So it means P is going to be positive. Because why? How, when I find my asymptote, I'm saying x plus P, it is equal to 0. Then x, it is equal to -P. Okay? So if x, it is equal to -2 here, okay? Then if I were to substitute thereof, I'm going to say -2 is equal to -P. Then P is equal to 2. Okay? And remember, if you were given the value of P, let's say you're given x plus 3. Okay, when you go to when you want to sketch the, or rather when you want to find the asymptote, the equation of the asymptote, we're going to say x plus 3, it is equal to 0, where x is equal to -3. Or just, you are just told by your teacher that when it is positive here, it's negative there. So that's how you just equate it to 0. Okay, so our P is positive 2, and then our Q is -1. Beautiful stuff. I can remove this now because I have now emphasized that. Okay, and then let me see. 4.2, calculate the value of what? Calculate the value of A. How can I calculate the value of A? Let me say f of x Okay, remember I already have f of x to be equal to a, and then I know p is 2, and then minus 1. So I'm going to just do what? Substitute any point that I see on the hyperbola, which is -4 and -5 divided by 2. So when I do that, it becomes y is -5 divided by 2. A is what I'm looking for, and then x, it is -4 plus 2 minus 1. And then I transpose the 1 to the other side. -2.5, this is -2.5 plus 1, it is -1.5, which is -3.2. It is equal to a divided by, this is -2, okay? And then a is going to be equal to, when I multiply by -2 on the other side, so it's just going to be +3, by the way. And then I can say f of x, I can confidently say f of x, it is equal to 3x plus 2 minus 1. But the aim was to find the value of a for 1 mark. Oh, okay. Now, does it make sense that the value of a is 3? Well, the value of a, if it is greater than 0, it lies on quadrant 1 and 3. If the value of a is less than 0, it lies on quadrant 2 and 4. So in this case, yes, it is 1 and 3, so it's fine. Okay. Write down the range of f. Well, the range and domain, the range of a hyperbola, okay? The range of a hyperbola, it is y is an element of real numbers, but y should not be equal to the asymptote. Where is your asymptote? Let me show you why we are saying that. Values of y are here, okay? So it is from -infinity, and then it goes all the way, and then when it's supposed to reach -1, it jumps and continue to -infinity. So to positive infinity. So you can say y is an element from -infinity to -1, and then continues from -1 to infinity. But it does not touch -1, hence I excluded those, okay? But instead of writing it like this, you can say y is an element from -infinity to infinity, but y should not equal to -1, or you can say y is an element of real numbers where y should not be equal to -1. This is why I answered it like this. Not touch my asymptote. Even if they were to ask you about the domain will also follow the same pattern. It starts from -infinity, it goes all the way, but instead it does not touch -2. So domain is from -infinity all the way to -2, that does not touch, and then or continues from -2 all the way, it jumps, and then it goes to infinity. Or you can say x is an element from -infinity to infinity, but x should not touch my asymptote. Like here, or x is an element of real numbers where x should not touch -2. This is the same answer, just written in different version of the thing is the of. All right. And by the way, I don't know why I feel like this is a axis of symmetry, because it passes through the point, the of. Okay, we are not there yet. Determine the equation of the line. Okay, determine the equation of the line of symmetry of f for m is less than 0 in the form of y is equal to something. So when m is less than 0, they are telling you that, this tells you that your negative gradient. Remember, when something is less than 0, it is negative on a number line. If this is 0, when you are less than 0, it means you are negative. When you are greater than 0, it is positive. And then remember, we get these things easier. We just go to our equation and take this thing. We just go to our equation and take this thing. If it has a positive gradient, we just say y is equal to positive gradient. We just put x plus 2 as it is minus 1. This is when we are having a positive gradient. But if I'm having a negative gradient, I'm going to say negative first and then x plus 2 minus 1. This is when I have m is less than 0. So now I'm interested in this one where m is less than 0. So I'm going to take this one. Okay. So I'm going to take this one and put it here. And then I now become a mathematician. Y is equal to negative x minus 2 minus 1. And then y is equal to negative x minus 3. I'm done. I'm done. Or I can use y is equal to mx plus c. Remember, the one with a negative gradient will pass through this point. It will pass through this point here. It will pass through the point of intersection between our asymptotes. And then if it passes through that one, then it means I already have the, and remember, by the way, the one with a positive gradient, which is this one, I believe, it is always y is equal to x plus c. It always has a gradient of 1. And then the one with a negative gradient, it always has negative x plus c. So it's just a matter of us of finding the value of c. So I already, with a negative gradient, when m is less than 0, it should be y is equal to negative x plus c. For me to solve for c, I'm going to need to sub any point on that graph. Any point on that graph, it is this one, the point of intersection -2 and -1. When I sub -2 and -1, y it is -1, x it is negative into -2 plus c, and then -1 it is equal to 2 plus c, and then c it is equal to -3. Therefore, the equation, it is, I'm going to come here, x is equal to -3. Therefore, the equation is equal to -x minus -3. Okay, so you can do this in many ways, 2 ways. Find out the equation of the asymptote of this one, okay? Remember, the asymptote of the original one was original. Let me say f of x had the asymptote of x is equal to 2, no, -2, and then y is equal to -1. But I want now of f of x plus 4, 1 over 2. Remember, what do we know? In functions, when I add on the value of x, it means now I'm moving 4, 1 over 2 towards the left. Remember, when I'm adding on functions, when I add to the value of x, I move towards the left. So it means the asymptotes are going to be, the x is going to shift towards the left. It's going to be -2 minus 4. I'm going to shift towards the left by those units, which now becomes -2 minus -9 divided by 2. It becomes something like, let me see on my calculator fast. Okay, it becomes -2, sorry, -6.5. But do you agree that the value of y remains unchanged? It is that, okay? Or someone might say, let me find f of x plus 4.5. So it's going to be 3, where I see x plus 2. Remember, normally it is x plus 2. The original it is x plus 2. So I'll just add 4, 1 over 2 minus 1. It will be 3 into, divide by, sorry. Then it's going to be x plus 6 half minus 1. And then you can say, therefore, asymptote is x is equal to -6 half. Okay? And y is equal to -1. Let me see if I, yes. So can you see now, whether you look at it like this and then find them, or you just now understand the translation thereof. What's important is that x, it is equal to that value, and then blah, 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 blah. I'm done. Question 5, parabola and whatever. F of x, it is equal to 2x squared minus x minus, this is a parabola. And then y is, g of x is equal to 3x minus 9 divided by 2. This is a linear function. And then this is a log function. Remember, log is the inverse of exponential. Inverses. And in inverse of exponential, it is log. So write down the coordinate of the turning point of f. Okay, the turning point of f, the coordinate of turning point of f. Okay, we know, guys, for turning point, I can use f prime of x, it is equal to 0. Okay, I'm going to show you 2 steps. You know, at the turning point, the derivative is equal to 0. So the derivative of f, it is what? 4x minus 1, it is equal to 0. And then x is going to be equal to 1 divided by 4. And then I need to output the value of y going to the original formula. okay, to find the value of y when x is equal to 1 over 4. So it's going to be 2 into 1 over 4 squared minus 1 over 4 minus 15. Then I get that the value of this one, it is just negative 121 divided by 8. So the turning point, it is 1 over 4 and negative 121 divided by 8. Or someone might say, oh, now I like this way. Negative b divided by 2a. When negative b, it is negative 1 divided by 2a, it is 2. And then this gives us 1 over 4. And then the procedure becomes the same. Here, you substitute back to that. So it's going to give you negative 121 divided by 8. And then the coordinates are the same for my turning point. Okay. Beautiful stuff. Okay. This is an or. Yeah. Whichever method that you prefer. Show that the x-coordinates of the x-intercept are this and this I. They just don't want to give us marks. So remember, for x-intercept, you let y equal to 0. So 2x squared minus x minus 15. Then factors of, that gives me negative 1 of negative 8, such that when I subtract them, 6 and 5. Then divide by 2, divide by 2. So I'm going to have x plus 3. Okay, okay. Minus 3, and then 2x plus 5. It is equal to 0. Okay, and then x, it is equal to 3, or x, it is equal to negative 5 divided by 2. Let's cheat. How do you cheat? How do you cheat? You already know the x-intercept are x, it is equal to 3, and x, it is equal to negative 5 divided by 2. So what you can do, you can say, okay, the first factor, it's just transpose x minus 3, it is equal to 0. So you already have your first factor here. And then when you come here, this is negative 5 divided by 2. Instead of transposing at the same time, you multiply by 2 first. So it's going to be 2x, it is equal to negative 5. And then you transpose the 5. Then it's going to be 2x plus 5, it is equal to 0. This is your factor. Okay. This is when I don't want to do the basic mathematics. Okay. Sketch the graph of f, g, and h. Graph of f, g, and h. Let me make individual sketches. The graph of a parabola is going to look like this. Since it is a positive gradient, it's going to look like this. Positive gradient is going to be smiling. And then this is a linear equation with a positive gradient. It's going to be like this, straight line. Okay? And then this one is the graph of log. Remember, I tell my students that when you're having an exponential function with y is equal to 1 divided by 3 to the power of x, this is a decreasing function. So if it is a decreasing function, I'm going to throw it like this. It's going to decrease. So also its inverse, it is y is equal to log 1 over 3 to the power of x. It's going to also increase. But now, instead of increasing, remember this one has a restriction that y should always be greater than 0. It does not touch this line. Okay? So it means now, if it does not touch the x-axis, the graph of y, which is my exponential, remember whatever that you do on the graph of f, okay, whatever x of the f, whatever x of the let me explain it like this. Whatever that you do with the x on the original function, it is what you do with the y on the inverse. Because remember, when we go to the inverse, we swap x and y. So it means if this one does not touch the x-axis, let me label this. If this one does not touch the x-axis, it means its log is not supposed to touch the y-axis. And it is decreasing. So this one will also decrease like that. So this is how our function should be. It does not touch the y-axis. So let's try to have a beautiful sketch. Okay, let's try to have a beautiful sketch there. I'm going to start with a parabola. Okay, I'm going to start with a parabola. Why a parabola? Because it has the turning point at where? It has turning point at 1 over 4 positive 1 over 4 and negative 121. Okay, negative 121 divided by 8, it is approximately, let me use this, 121 divided by 8, it is approximately 15.111. So it's going to be 1 over 4, let's put 1 over 4 here, and negative blah, 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 let's put it here. So my turning point is going to be somewhere here. And then let's look at the y-intercept. The y-intercept, it is this value. Remember this, if this is remember this is the graph of f of x, it is equal to 0. So it's going to be here. This is my y-intercept, okay? Remember my y-intercept, if it is in the form of ax squared plus bx plus c, it is my y-intercept. So my y-intercept is negative 15. Remember, this is approximately negative 15.125. So negative 15 will not be far away. Okay. And then the x-intercept, it is 3 and negative 5 divided by 2. Negative 5 divided by 2, it is the same as negative 2.5. So negative 2.5 is going to be somewhere, let me put it here. And then it has positive 3. Positive 3, let us put it here. And then let's join. Let's join our function. Okay, I feel like it's too much. Let's put it here. Okay. Okay, yes, I was coming on right. Let me do this. Okay, let me try that again for the last time. Not bad. Goes all the way. And then let's try to minimize this again, Ileona. Let's say this somewhere here. Okay, so my graph should move all the way, come there, and then go all the way. Okay, and then I'll just label this as my graph of f. Let's go to the graph of linear function. The linear function has an equation of 3x minus 9 divided by 2. Let me just confirm. 3x minus 9 divided by 2. So am I that far? 3x 9 divided by 2. Yes. So the x-intercept, I let y equal to 0 for x-intercept. Okay, I let y equal to 0. Let's try to see that. For x-intercept, I let y equal to 0. So I'm going to have 0 is equal to 3x minus 9 divided by 2. This is for x-intercept. And then I'm going to have 9 divided by 2 is equal to 3x. Divided by 3, x is going to be equal to, when I divide by 3, it's the same as multiplying by 1 over 3. It's going to be 3 divided by 2, which is the same as 1.5. So 1.5, it is y-intercept. 1.5, somewhere in the middle here. And then let's look at the x-intercept, y-intercept rather. The y-intercept, you let x equal to 0. When you let x equal to 0, then the y-intercept is going to be negative 9 divided by 2, which is negative 4.5. So negative 4.5, it is somewhere here. Let's put it somewhere here. And then let's try to join a straight line between these two. Okay. Use different color just for inconvenience. That should be good. That should do. Okay, let me extend it a little bit. Okay. This is my graph of G. And then last one, the graph of log 1 over 3x. Guys, if you're not sure how this graph is, look at the graph of y is equal to 1 over 3x. It looks like this. It is a decreasing function. And it has a coordinate of 1 here. So its inverse, guys, it's going to decrease also. But it does not touch the x. It's going to decrease like that. And this coordinate, remember this coordinate, it is 0 and 1. So this coordinate, sorry. If this coordinate it is 0 and 1, this one, If this coordinate is 0 and 1, remember on the inverse, it's going to swap. So it's going to swap and become 1 and 0. So this is what you can only draw. So you can draw that and say, okay, at 1 here, it's going to cut here somewhere at 1. And then let's have another color for that one. That's green. Okay. So we know it's going to be a function that cuts here, goes all the way. And then I can just say this is my graph of H. Oh, beautiful. Oh, let's look at the results. Okay. Oh, this is marvelous, guys. I outdid myself. Cool. 5.4. I'm still cruising nicely so far. 5.4, go back to my normal color that I like. If H is a point on G and R, okay, if point H is a point on G and point R is a point on F, such that the abscissa, okay, abscissa, very bad word they used. Abscissa just refer to the x-intercept, okay? The x-intercept, or let's just say, refers to the x value. The x value of both points is 4, okay? The x value of both points is 4. Determine the length of HR between G and what? G and F. G and F. Let me try to have a sketch of G and F. Name? Just a quick sketch of G and F so that it makes sense. So that my calculation, when I start doing calculations, you will understand what I'm basically doing. So that it will make sense. So remember my G was something like that. And then my H was something like, my F, sorry, was something like that. So the question is, if H is a point on G and R is a point on F such that the X value is 4. So remember here the X value of this one was, the Y-intercept was 3. So if it is 4, it is somewhere here. So if X is 4, we have point H on G, point H on G. Okay, this is point H on G. And we have point R on F, such that the X value is 4, somewhere here. R. Okay, determine the length of HR. So it forms now a straight line here. Okay, let's try to zoom out. Let's try to zoom this section. When we try to zoom this section, we are having something like this. When we try to zoom that section, we are having something like this. And then, okay, when I zoom that in, this will be just a straight line like that. Where this is R, this is H. And remember the x coordinate thereof, the x coordinate of both of them. I know the x coordinate of both of them, it is 4. Let me call this y of r. And then the x coordinate of this is 4. And then y of h. Now they want me to calculate what? Calculate the length HR. And guys, you need to be careful that you need to be aware that this is just a straight line. How do I know it is just a straight line and it is not just good? It is because they have the same x value. So x value is the same throughout here. So how can I calculate this? So let me make a box for my calculations here. How can I calculate this? How I can calculate this is, okay, let me find the value of, by the way, this is the function of f, not h, f, and this is a function of g. So I'll say, okay, let me find the value of f, the value of y, okay, y of f, when x is equal to 4. So I'm going to say y of f, I'm going to need to locate my equation of my parabola. Okay, remember the equation of the parabola was 2x squared. So I'm going to say 2x is going to be 4 squared minus x, which is 4, minus 15. So this will give me 2 multiplied by 16, it is 32. 32 multiplied by 19, 32 multiplied by 19, it is 20. Okay, 32 multiplied by 19, 20. No, sorry, it is 13. And then let me find, okay, this is not y of r, but rather y, or not y of f, y of r. Okay, let me find y of h. Okay, y of h here. So I'm gonna need my straight line equation. So my straight line equation was 3x. So I'm gonna substitute 4 minus 9 divided by 2. Then it gave me something like 12 minus 4.5. It is 15 divided by 2. 15 divided by 2, which is the same as 7.5. So the distance between this one and this one, remember for a vertical distance, I need y top minus y bottom. This is going to give me the distance. If this is r and h, so this is going to give me the distance hr. So distance hr is going to be equal to what? The top one, it is this one, minus 7.5. Let me just say 15 divided by 2, and then it's going to be 13 minus that. It's going to just give me 11 divided by 2. So RH, RH or HR, it is equal to 11 divided by 2. I hope I simplified this question as much as possible. Okay? Or what you can do, you can say the equation of f is above. So you can say HR, it is equal to f of x minus g of x. You'll see after doing that, you'll find that f of x minus g of x will give you an expression that looks something like this. It will give you an expression that looks something like 2x squared minus 4x minus 1021 divided by 2. And then you need to sub 4, okay? Because you already know the value of x. You need to sub x, it is equal to 4. And then you'll see 4 squared minus 4 to the power 4 minus 21 divided by 2. This will give you 11 divided by 2. Okay. Okay, so that's that, guys. That's that. Oh, by the way, 11 divided by 2 is the same as 5 halves. Okay, just remark 11 divided by 2 is the same as 5 halves. So as to, if you get that. Write down the domain of H inverse. H inverse is what? Okay, H inverse, if this is the graph of log, now they want the domain of H inverse. Now, what I normally tell my students is that the domain, okay, if I'm looking at the inverse, let me look at the H, the graph of H. Ne? The domain of H and the range of H. The domain of range, it is the same as the range of my inverse. And the range of H is the same as the domain of my inverse. What do I mean? If now the domain of, this is just a typical example. If the domain of F, it is X is an element of real numbers, it means now the range of the inverse is going to be Y is an element of real numbers. So what do I mean here? What do we want? We want what? The domain of my inverse. And we do not have an inverse function here, but rather I can translate the inverse function to the range of what? Of H. Okay? Okay, let's check. What is the range of H? The range of H, it starts from negative infinity. Our function starts from negative infinity, the values of Y, and it goes all beyond to infinity. So the range, okay, the range of H, let me put it like this. The range of H, it is equal to from negative infinity to is the same as Y is an element of real numbers. Therefore, the domain of the inverse will now be X is an element of real numbers. Okay, or someone might write it like this. Y is an element from, what's important is this one, by the way, the domain. X is an element from negative infinity to positive infinity. So you do not need to know how to the graph, but you can sketch the graph. If you know this one is a decreasing function like this one will also have a decreasing function like that. This is the inverse. So this is h, its inverse is going to be exponential. So can you see the domain starts from negative infinity to all the way to infinity? Beautiful stuff. So the answer is here. You don't need the top part. The top part is just to remind you. Okay? Just reminder. Or if you want to simplify your mathematics, then what is the range of h? The range of h is going to be the domain of h. What is the domain of h? Let's go look at the domain of h. The domain of h, the function starts from x is equal to 0. This does not touch that all the way to infinity. The values of x, can you see, they do not start from negative infinity. They start at x is equal to 0 to positive infinity, but x is not equal to 0, so it does not touch. So the domain of h, it is x is greater than 0. Everything, when x is greater than 0, we find our function. Or someone might put it like this. X is from 0 to infinity. Okay. And then, but remember, the question is about the range. The range of the inverse is going to now be y. We just change to y. It's greater than 0. Or someone might say y is an element from 0 to infinity. Your answer is this one, by the way. All right. So these are your answers. These are your answers. So determine the values of k if the roots of this one are equal. Remember, for equal roots, the discriminant, which is equal to b squared minus 4ac, is equal to 0. So we need to output that b squared minus 4ac is equal to 0. B, it is how much? How much is b? B is negative 1. So I'm going to say negative 1 squared minus 4a, it is 2, c, it is k. Then this is just 1 minus 4 times 2 times k, it is 8k, is equal to 0. And then negative 8k, it is equal to negative 1. Then k, it is equal to 1 divided by 8. And now the discriminant being equal to what? The discriminant being equal to 0. So whichever method that you use, okay, the condition needs to be cleared off. All right. Then I think this is the last question. Yes, calculate, determine the maximum value of g of x minus f of x, okay? Normally when they want the maximum value, what you do, let's say this is height. Let's say, let's call it distance. Distance with respect to d. Okay, g of x, remember g of x, it is what? G of x, it is 3x minus 9 divided by 2. Minus, you put a bracket, and then f of x, it is 2x squared minus x minus 15. And then you simplify your mathematics, you'll get that you get negative 2x squared. 3x plus this, it is just 4x. And then negative 9 divided by 2 plus 15, it is just 10 divided by half, which is just plus 21 divided by 2. And then for maximum, okay, remember this is just a parabola, okay? The sketch of this one, it is a parabola that is said. So for me, okay, let me put it here. For me to find the maximum value, I know at the maximum value, the first derivative, it is equal to 0. Remember, the derivative, it is the gradient. The gradient, it is equal to 0. So now I need to find the first derivative. And it needs to be equal to 0 because it is at the maximum. So I'm going to say it is negative 4x squared minus, or rather, sorry, plus 4. It is equal to 0. This is 4x plus, it is equal to 0. And then x will just be equal to 1. And then if x it is equal to 1, I need to come back to my dx formula. Okay, then substitute d of 1. Negative 2 into 1 squared plus 4 into 1 plus 21 divided by 2, and then you'll see that the maximum value is going to be something like 25 divided by 2. Okay, 25 divided by 2, which is the same as 12 halves or 12.5. Okay, let's move on. 6.1. If given f of x is equal to 3 to the power of x, this is exponential. Determine the inverse in the form of this one. Remember, guys, I told you that if you're having exponential is equal to this, for you to find the inverse, you just say log and write everything exactly as it is. So sketch the graph of f and the inverse. Show all the x-intercept and the what, and the asymptotes. So this one, it is an increasing function again. So if actually, let me say, if a is between 0 and 1, it is a decreasing function. But if a is greater than 1, it is an increasing function. So how do I confirm? Remember the last time we worked with the inverse. Remember I told you that this is just log, but this function, the inverse of that log, it was the exponential, which had y 1 divided by 3 to the power of x, and we said it is a decreasing function because the value of a was between 0 and 1. But if the value of a is greater than 1, it's going to be an increasing function. So this is just easy, guys. This was just easy for marks given to you. You don't need to think. Yes, you don't need to think. So I know the graph of f is an increasing function, so it's going to increase in this manner. Okay, this is the graph of f. And remember the coordinate here, it is always the coordinate here. It is always what? It is always 1. Or you can say it is 0 and 1, the coordinate here. Okay, and now if this is increasing but does not touch the x, it means the inverse will also be increasing but not touch the y. So it will be increasing but does not touch the what? The y. Okay, and this point here, it will be this point, but now reflected across this line. Remember, we have this line that passes here, and this line, we call it y is equal to x. So it is the reflection. The graph of f, it is the, okay, let me say the graph of the inverse. It is the reflection of f across the line y is equal to x. And then this point will just interchange x and y. It's going to be 1 and 0. Then we are done, guys. Okay, you are done. So they just asked us to show all the intercepts with the axis. Okay, we have already showed them. Here are they. And then asymptotes, here are they are at the y-axis as well as x-axis. So I cannot show them any further. The shapes, very important, just easy for marks. Okay, you don't need to show this line, but you need to know that the inverse and as well as the original function, for you to find the inverse, you need to translate that function, the original function, about the line y is equal to x. They say write down the equation of the line of symmetry between the two graphs you have drawn. So the line of symmetry, remember, line of symmetry is the line that divides the two graphs into equal. Okay, so it's this one. Okay, it's basically that one. And I just said that one. Which line is that? I just said that the line has an equation of y, it is equal to x. Okay. Okay, so this is the line of symmetry between the two graphs. It forms a mirror thereof. And then they are saying, for which values of x will f of x multiplied by the inverse be less or equal to 0? Remember, less than equal to 0 means the outcome needs to be negative. For the outcome to be negative, this should be positive multiplied by negative, or negative multiplied by positive. But now when you check at the graph of f, the graph of f is always positive. Okay, we are talking about the values of y is always positive. So this condition cannot happen, this one. This one cannot happen because f of x will never be negative. So it means we need to consider this function, this condition, where f of x is positive. F of x is positive on its domain. And then we need to consider where is, again, we are saying we want where f is positive and where the inverse is negative. So the inverse is negative where? From 0 to all the way to 1. So the question is, where do they occur at the same time? When do the plus of f and the minus of the inverse occur at the same time? Can you see that in this region, they occur at the same time in this region here, and then between these points here? So can you see this one is positive, whereas this one is negative? So between 0 and 1, okay? So between 0, we are talking about the x values, between 0 and 1, that's where we find that. So between 0 and 1, we find that. Okay, between 0 and 1, we find that. So I'm going to answer this question by saying x is an element of, now remember it is included again, so 0 and 1. I'm going to only include 1 because my graph are defined at x is equal to 1. But why am I not including 0? Because when I include 0, do you agree that the inverse does not touch 0? So I cannot include that as part of my solution. So even though it is included, but 0 is an asymptote. Remember, x is equal to 0 is an asymptote for the graph of inverse. So it will not form part of the solution. Hence, we use a round bracket. A round bracket like that. Okay. You don't need all this theory. You just need to understand that. Okay. All right. Or someone might write it like this. X is between 1 and 0, including 1. Okay. Let's move without wasting any time. Write down the range of 3 to the power of negative x minus 1. So this function can be rewritten as, remember 3 to the power of x can be the same as 1 to the power of 3x minus 4. So if you want a typical sketch of how this looks, it is a function that is decreasing, but now it has an asymptote at negative 4. So I need to say this is my function, but it has an asymptote at y is equal to negative 4. And then this is x, this is y, so it's going to decrease. Let me use a different color. It's going to decrease, but does not touch the asymptote like that. Okay, so what is the range? The range is the range of h is going to be y is an element from, it starts from 4 all the way above, but does not touch 4, negative 4 rather. Does not touch negative 4 all the way above. Or someone might say y is greater than negative 4. Then they say write down the equation of G. If the graph of G is the image of F, after F has been translated 2 units to the right and reflected across about the x-axis. So they found G by doing what to F? By firstly translating it 2 units to the right. So 2 units to the right. Remember when we moved anything, okay, we are talking about the graph of F. They moved it 2 units to the right. Okay, to the right, it is the x values. So to the right, remember, it is minus 2. Okay, so every time when we move to the right, we minus. When we move to the left, we plus. And it is also reflected across about the x-axis. Remember when I have a point? When I have a point here, when I reflect it across the x-axis, what changes, let's say it has coordinate A and B. What changes, the coordinate of the x coordinate is still A, but the y coordinate is now negative. So it means now they changed this one to being negative. So it was negative. The value of y is now negative. So let's write the equation. The equation is going to be negative. What is f of x? Originally, we know f of x to be, we know f of x to be 3 to the power of x. So f of x is going to be negative 3 to the power of x minus 2. Okay, so if you just write full answer, it's still fine. What's important is the answer. Okay, it is translated 2 units to the right, and it was reflected across the y-axis. How do I know that? Because f of x, if I reflect it across the y-axis, sorry, reflect. Let's start here. Let's start. Let me make this make sense. Reflect across the x-axis. It changes to f of x changes to negative f of x because now the y value changes from being positive to negative. Okay, and then they do what? Translate 2 units to the right. 2 units right. 2 units right is gonna be, already we are having negative f of x. Okay, so 2 units to the right is gonna be negative f, and then x minus 2. Hence now what we have there, and this is just what? This is g of x. Good. This should be fairly beautiful. Question 7. A business buys a business buys a machine that costs 220,000. The value of the machine depreciate at 9% per annum according to diminishing balance method. Okay, diminishing balance method. Now they are using very bad words. Okay, diminishing balance method just refers to. Okay, I don't like the words that they use. Just refers to reducing balance method. And remember the reducing balance method, it is the compound angle, it is the compound formula but with and minus. So what is the scrap value? Okay, the scrap value is the value that it is worth after it has depreciated. So A is equal to P into 1 minus I to the power of N. Okay, this one, A is equal to P into 1 minus IN. This is what we refer to as straight line method. Okay, so we are not going to use the straight line method. Okay, then let's just become mathematicians. Remember, this 120, it is your principal amount. This is the P value, the initial value. Okay, this is the initial value. Let me do like this. This is the initial value. And then the 9%, it is your interest. And you need to divide that into decimal, 0.09. And always depreciation and inflation, it is annually. Okay, it is annually. So you divide by 1 or multiply by 1. Okay, so it's just going to be A, and this value for depreciation, okay, let me do this. For depreciation, the value that you start with is always greater than the amount that you're gonna end with. Okay, so the initial amount is greater than the final amount. So it means if you buy it with 120,000, after 5 years, it will be worth less. It will worth less because it has depreciated. Okay, so 120,000, 1 minus the interest, it is 0.09 to the power of how many years? 5 years. And then your accumulated amount will just be reduced to 74,883.86. Okay, so substitution and answer. After 5 years, the machine needs to be replaced. Okay, okay, this question looks similar to a sinking fund, where when you have a calculator, okay, let me say where you have a laptop that you bought at 25,000, and then after 5 years of completing your degree, you want to replace it with a new calculator, okay, so new laptop. So when you sell this laptop, it's gonna be worth maybe, let's say, Boma 13,000 or 10,000. But at the store, you'll see that maybe it is something like 1,000. So you need to find the difference and need to save for a particular amount. Okay, when you say that 1,000 minus the 15,000, the 10,000 that you bought it with, then it will see that this is 21,000. So you will need to save. You need to save 21,000 immediately after buying this one, so that when you sell this one, you add the money that you saved and buy the new one. Sinking fund works like that. If you are not sure, there is a video under financial mathematics where I explain this. So after 5 years, the machine needs to be replaced. During this time, inflation remains constant at 7% per annum. 7% per annum. Determine the cost of a new machine at the end of 5 years. So we know inflation is just simple. compound formula A is equal to 120,000, and something inflates, it means its value increases. By the way, I it is 0.07 to the power of 5, and then value of A needs to be created down 120,000, so needs to be 168,306.21. And then they say now the business estimate that it will need approximately 90,000 by end of 5 weeks. The business estimates that it will need approximately 90,000 by the end of 5 years. Okay, a sinking fund for 90,000 is into which equal monthly installment must be paid is set up. Okay, so basically, you know why they set up sinking fund. Remember here, they had an inflation amount. This is inflation. This is depreciation. So when you want to buy the same machine after 5 years, you need to say inflation minus depreciation. This is what you sold it with. This is what it will worth after 5 years. So you're going to say this amount minus that amount. This will give you the amount that you need to save. So you need to open a future value account, okay, a savings account, so that you will do regular payments on it for the 5 years, and then so that you cover for this amount that you will need. Okay, so they say they opened what? A sinking fund that needs to be saved. So that sinking fund you need to save 90,000. Okay, so they will do equal installments. Okay, must be paid. So this is monthly installment. Okay, interest of this fund, it is 8% per annum, compounded monthly. Okay, first thing first, the sinking fund should be 90,000, and then the interest, it is per annum, compounded monthly, and then the first payment will be made immediately. Okay, that is bad. And the last payment will be made at the end of 5 years period. That is good. Now, before we do any calculations, let's collect the data. So the sinking fund is the same as future value. You need to open a future value account where you will do regular installment, and then the interest, it is 0.085, and it is compounded monthly. I'm going to divide by 12, and then X, which is now monthly, what I do not know. This is what we are supposed to calculate. Calculate the monthly payment. So you're gonna calculate that. 2, okay. And then we need to know N. Okay, N is supposed to be 5 years. Okay, for 5 years, but multiply by the number, the compound, the period of interest, which is 12. But now, if you pay immediately, let me explain. If you open a savings account, if you open it today, let's say you open your savings account in January. In January, you open. And then in February, you start with the initial saving up to 5 years. But if you open and start immediately, so if you okay, let's say when you open in January and then start in February for 5 years, this will be 5 multiplied by 12, which is 60 payments. Okay, or 60 months, 60 payments or months. But now when you start immediately, you are adding that one. You are adding that one. So instead of just 6, you are adding that one. That immediately you're just adding one. So it means now the number of payment will be 5 times 12 plus 1, which is just now 61 payments that you're going to do. And if you ended early, let's say you ended 2 months earlier, so you're going to say plus 1 of immediate and then minus 2 of ending earlier. Okay, yes. Okay. And when you end earlier, the amount that you get, okay, when the amount that you get, you need to accumulate it for that particular interest for that 2 years. So for that 2 months that you left it in the bank, because you're not going to withdraw it, you're going to wait for the rest of 5 years, and then it will just go on itself. So let's focus on the scenario that we have. So calculate this. We know this is future value because they're trying to save for how much? For this amount. So I'm going to say F, it is equal to X into 1 plus I to the power of N minus 1, all divided by I. My future value is 90,000. X is what I'm looking for. And then 1 plus my interest, it is 0.085 divided by 12. The number of payments is going to be 61. Very important. If it's not 61, you use 60, then unfortunately it's going to be wrong. Okay. And then minus 1, all divided by 0.085 divided by 12. So what I want you to do is say X, okay, X is just equal to 90,000 divided by all of this part, thereof. Okay. So when you do that and do your mathematics, you'll get that the monthly installment will be something like 1,184.68. So how do we mark this? Now the value of I and N correctly. Okay, I and N are correct. I and N are correct. And then substitution of everything is fine. Okay, 1 mark for I it is equal to 0.085 divided by 12 and N it is equal to 61. So this is your first mark. Your second mark, you have substituted correctly. Correct substitution. Okay, irrespective of whether you use 61 or 60. But you're going to lose 1 mark. Then, Kasala, or sorry if I pronounce that word wrongly, Kasala receives an amount of 900,000 upon her retirement. Mudimu. She invested, and then, okay, this is the amount that she get after retirement. And then you are told that, sorry, you are told that she invests this amount immediately at an interest rate of 10% per annum compounded monthly. Okay, sorry, okay. And then they tell you that she needs an amount of 18,000 per month to maintain her current lifestyle and plans to withdraw the first amount at the end of each month. Okay, for how long, for how many months will she be able to live all of her investment? Okay, now here's a scenario. Here is Miss Kasala. Ne? Miss Kasala has 900,000 for retirement. And now she invests that to the bank. Okay. So she invests that to the bank. And you know that when you invest the money to the bank, it's going to grow. Okay? So it's going to grow. So at an interest of 10%, 10.5%. Okay? And we are not told that she's going to invest for how long. Okay? But now what you are told is that she will need, of the 900,000 that she has invested, she will need 18,000 per month from it. Okay, so it means now, remember this money when you invest it into the bank, it will grow again. But as it grows this month, she withdraw 18,000. The other month is gonna grow again. She withdraws 18,000. So this scenario is the same as, okay, take it like this. Okay, okay. Imagine it like this. Imagine it like this. Imagine it like this. Imagine it like this. Imagine it. Imagine Kasala, okay, loaning the bank. Okay, let me say the bank, okay, asks for a loan of 900,000 to from Miss Kasala. Okay. And then Miss Kasala says, it's fine, I'm going to give you the loan. But now you need to pay me each and every month, monthly installment. Okay. You are granted the loan, but you need to do monthly repayments. Remember, if you're taking a loan, you will need monthly installments. Of how much? Of 18,000 per month. So you're gonna pay 18,000 per month. So the bank has took a loan from Miss Kasala. Kasala, and Miss Kasala will now be paid by the bank each and every month 18,000 at an interest of 10.5%, which is the same as 0.105 divided by 12. Okay, monthly. Remember, it is monthly. Okay, then for how long? For how long will the bank settle the loan to Miss Kasala? This is what you are looking for. This is what we are looking for. So imagine it like that. So we just imagine that the bank took the loan from Miss Kasala of 900,000. So we're gonna say, okay, let us now, we know that for a loan it is 1 minus 1 plus I to the power of negative n, all divided by what? By I. And then the bank requires a loan of 900,000. And Miss Kasala had an agreement that they're gonna pay her each and every month how much? 18,000. Okay. And then 1 minus at an interest 1 plus at an interest of 0.105 monthly divided by 12, all raised to the power of negative n. And then let me just put this down here. All my imaginary scenario and everything basically. Okay. Let me take this everything, this scenario that I created for myself there off down here. Okay. So let's move my scenario down here so that it does not disturb us. Okay. So the bank took the loan of that much. This is not the real scenario, but it is similar. It is a similar concept. Okay. And then let's go through the mathematics. Let's go through the mathematics. Multiply this by that. So I'm going to say 900,000 multiply by 0.105 divided by 12. And then I'm going to get 78, 75. So after getting 78, 75, I'm going to divide by 18,000. Divide by 18,000. I get something like 35 divided by 8. Okay. This is after multiplying this and then dividing by 18,000. And then here inside the bracket, I'm going to have 1 minus 1 plus 0.1 plus 0.105 divided by 12. Going to give you something like 807 divided by 800 to the power of negative n. Okay, then I'm transposing this to the other side so that it becomes 807, sorry, divided by 800 to the power of negative n. It is equal to 1 minus 35 divided by 8. 1 minus 35 divided by 8 is the same as negative 127. Sorry, negative 27 divided by 8. And then remember, if I want to solve for n, it's going to be negative n is equal to, when I drop it, I need to drop it legally, log. This remains the base. And then this will be negative 21 divided by 7. And then negative n is equal to, let me see, log of 807 divided by 800, all raised to the power of negative 21 over 7. Okay, it gives me an error. Okay, by the way, this is bad for having a negative. So applying the rules of, if I apply the rules of, what do we call this? I'm not sure if you are taught those rules. I can bring this one down here. Okay, I can bring the negative 21 down like that. So let me try. Put it negative 21 divided by 7, then log, the normal log, 807 divided by 800. Well, it's bad. Okay, let's try to find another way of doing this mathematics, okay? Let's find another way of doing this mathematics. Unless I did some mistake in my calculation. Okay, where is this part? And let me say 900,000 multiplied by 0.105 divided by 12, and then divided that by 1800. Oh, this is 7 divided by 16, by the way. 7 divided by 16, not what I wrote. And then 1 minus 7 divided by 16. When I transpose this, it's going to be positive. 1 minus 7 divided by 16. It's 9 divided by 16, okay? And then I can say negative n is equal to log. Then I can now substitute 9 divided by 16. And then I can now go to my calculator again. 807 divided by 800 to the power of 9 divided by 16. And then I get negative 66.0432. And then n is now going to be equal to 66.0432, blah, blah, blah. But now, let's read the question. The question says, for how many months will she be able to live off her investment? So, remember, this particular person is trying to maintain his lifestyle. So, of 18,000. So, it means now, this particular person is going to have 66 monthly payments of the full 18,000. And this decimal will tell you it is one payment of an amount less than 18,000. So this is 66 monthly payment of 18,000 and one payment of an amount that is less than 18,000. So this is basically that you need to understand that. So, but now the question is not how many months will she get the full 18,000. The question says, for how many months will she be able to live off her investment? So for her investment, she will, the question says, for how many months she will have how many months she will be able to live on her of her investment investment for 67 months. Why? Because the 67 months, it is composed of 66 full month payments of that one, 66 monthly payment of full amount, and one payment less, which we do not know. So in amount is going to be 67 months. Guys, some people will have used future value and compound value formula if you do not understand this scenario, but I want to believe you are now fine. 8.1, determine f prime of x from first principle. I don't like doing this question because everyone knows it. Unfortunately, some people do lose marks. Now, the expected answer, it is negative 4x plus, negative 4x using rules. Okay, using rules, the expected answer is negative 4x. If you do not get negative 4x, then something is wrong. What I like to do is start first by finding f of x plus h. Okay, f of x. Okay, f of x we already know. Let's find f of x plus h. Where we see x, we're going to open a bracket and substitute x plus h squared plus 1. So this will be negative. When you simplify this, it's going to be x squared plus 2xh plus h squared. Let me write that again. So when you multiply that by 2, it's going to be negative 2x squared minus negative 2 multiplied by 2x squared, negative 4xh minus 2h squared plus 1. Okay? And then you need to come here and say, then how much is f of x plus h minus f of x? So it's going to be negative 2x squared minus. The reason I'm simplifying it here is because I don't want you to cause troubles in the formula there. And what I like to tell my student is when you do f of x plus h minus f of x, whatever that you have here should be completely removed in the equation thereof. So let's see if that's true. It's going to be, this will be negative by negative. This will just be plus. Negative by that is going to be minus. So it's going to be negative 2x squared plus 2x squared. It cancels. Negative 4xh with no like term. Minus 2h squared. 1 minus 1, it is 0. Can you see that we no longer have the negative 2x squared plus 1, so it needs to cancel off. And then, but we still need to go back to our formula that says to us limit as h approaches 0 of what? Of f of x plus h minus f of x. And it's fun because we have already simplified what is f of x plus h. So it's just a matter of us continuing with now the what? The substitutions thereof. F of x plus h, it is what? Negative 4xh minus 2h squared. Divide that, okay, all divided that by h. And remember the target, the aim it is to remove h. Why? Why remove h? Because any constant divided by 0 is undefined. Because if I were to substitute h exactly immediately to be equal to 0, this will give me a constant divided by 0, which is undefined. So hence now I need to remove that. So I need to say limit as h approaches 0. How can I remove h? I just need h. Only one h from the top. I'm going to take h as a common factor. Only h. Do not take negative h, guys. Just take h. And then we are left with one h there divided by h. And then the h and the h will cancel off. So and then I'll have limit as h approaches 0. The h and the h will cancel. I'm just left with negative 4x minus 2h. And then remember when you substitute, you do not now introduce, you now omit the h. So you can say negative 4x minus 2 into 0. So when you substitute, you omit the 0 and then your answer is negative 4x. Okay? You can skip this step. If you don't like that step. So the answer that you got, is it the same as the prediction? Yes. Move on. And remember, guys, what does the first derivative mean? Actually, what does this mean? F prime of x means the gradient. Okay? But not at a specific point. So 8.1.2 says, hence calculate the gradient of the tangent to f at x is equal to negative 1. So what is the gradient of the tangent? Okay. Calculate the gradient of the tangent of f at x is equal to that one. Remember, when I have a function, this function that I have here, it is a parabola that is facing downwards. And they say I have now a tangent thereof. And now they are telling me at x is equal to negative half. Okay, let me put it on this side. At x is equal to negative half. What do I know at this point? At this point, I know that the derivative of a function at a specific x coordinate, which is indeed equal to, it is going to be equal to the gradient of the tangent. So the gradient of a function at a specific point is going to be equal to the gradient of the tangent. So, but I already know the derivative, it is equal to how much. So I'm going to just say it is equal to how much. So I'm going to substitute the negative 4 multiplied by negative half. Remember, I already know what is my first derivative, okay? So I just substitute when x is equal to negative half, and then I get a beautiful answer that is 2. So this was just very easy. Determine the derivative of f of x is equal to cube root of x squared plus 1 over 4. Remember what does the rules? Derivative rules. They say whatever that you are differentiating with respect to, in this case, you are differentiating with respect to x, should not be at the denominator. If it is at the denominator, you need to take that denominator and take it to the numerator, like this. Or whatever that you're differentiating with respect to, it is inside a radical. Let me say x to the power of 4. It is inside the radical. You need to remove that to x to the power of 4 divided by whatever that you have here, whether it is cube root of square root. If it is square root, it's going to be 4 divided by 2. Okay? And then the other rule, I think there are only 2 rules, if I remember them very well. Yes, these are the rules that we have. Okay, yes. So in this case, can we differentiate this? No, the rules do not agree. Why? First thing first, we have this condition, we have a radical. Why am I saying a radical? A root. Okay, what is a radical, by the way? Okay, I'm having a root. So when I have a root, I should not differentiate. When I have whatever that I'm differentiating with respect to, which is x at the denominator, I cannot. So I need to say f of x, not differentiating. F of x. You cannot differentiate until everything in the equation of f of x is set up beautifully. So this is going to be x to the power of 2. Remember, you're not divided by 3. And then plus 1 over 4. I'm just taking this x to the power of 4. I only care about whatever that I'm differentiating with respect to the top. So I can just say it is x to the power of negative 4. I can also put it like that. Can I now differentiate? Yes, everything is now in standard form. Beautiful. I now say f prime of x. It's very important that you say that this is f prime of x. Is now power rule says I multiply the power with the coefficient. This is 1, so it's going to just be 2 divided by 3. Let me write it here. It's going to be 2 divided by 3 x. Then I need to remove 1 from the exponent. 2 divided by 3 minus 1, it is negative 1 divided by 2. And then negative 4 multiplied by 1, it is negative 4. So negative 4 multiplied by 1 over 4, it is negative 1. And then x to the power of negative 4 minus 1, it is negative 5. Okay, so this is just 1, but you don't need to show that 1. Okay, so I'll just put it there so that you know. So first thing first, the first mark that you get, it is for you to writing this in a beautiful way. And then the other mark is differentiating independently. Given h of x is equal to ax squared, where a is greater than 0, so this is just a hyperbola like that. Sorry, a parabola like that. Okay. And then where a is greater than 0, okay, determine the value of a if it is given that h, the inverse of function at x is equal to 8 is equal to the derivative of h when x is equal to 4. But remember, for us to find an inverse of a parabola, I need to restrict this function. Okay, remember, if I were to draw the graph of an inverse, it's going to be like this, and it fails a vertical line test, so it's not a function. So I need to restrict this function of x. So it's either I restrict it here, okay, or I restrict it here. So it's either I choose that position. So I'm going to choose this position where x is greater than 0. So it means also here I need to choose a position where y is greater than 0. So I'm only focusing on the red positions, okay? So first thing first, let's now find independently what is this. Because for us to find the value of a, let's find this one independently and then come to this one and then we'll equate it there at the end. So first thing first, we need to find the inverse. So if I'm having y is equal to a to the power of x squared, which is this. So remember, I need to say interchange x and y. And then I'm going to need to divide that by a. And then y, remember, it is equal to plus or minus square root of x divided by a. Okay, but now y is greater than 0 here. Okay, let's come here. The value of y here, okay, it will either be greater than 0 or less than 0. But in this case, I think here they needed they missed something. They missed something. They missed a condition where x is greater or equal to 0, or x is less than or equal to 0. So because I needed that condition so that I know. Okay, I need this condition to know whether I'm dealing with this part or this part. By the way, okay, so I'm just going to continue such that a is greater than 0, x is greater than 0. So here, when x is greater than 0, meaning on the inverse, y will be greater than 0. So if y is greater than 0 on the inverse, it means here we'll just take the positive sign. So we'll just take the plus sign. Okay, yes, we just take the plus sign, x divided by a. And there is a restriction, by the way, but you don't need to put it. The restriction is that x should always be greater or equal to 0. Whatever value of x that you are inserting here should be greater than 0. What do I mean? Square root of whatever divided by a. If x is 1, then the square root of a positive number can be determined, okay? But if if x would be less than 0, then it will be -1. And I know I cannot have square root of a negative number. So this is undefined. Hence, I need to restrict this, but that's not important for now. And then let me evaluate. This is just the inverse, okay? And then let me evaluate the inverse at x is equal to 8. So it's just going to be equal to 8 divided by a. You agree with me? 8 divided by a. Okay. And then now let's output h prime of 4. First thing first, the derivative. The derivative, it is 2ax. Using derivative rules, a power rule, multiply by 2, it is 2ax, and then the exponent to minus 1. And then, now that I know the derivative, okay, I can say, okay, at 4, the derivative at 4 is going to be equal to 2a, and substitute 4, which is now 8a. And then now I can come to the step where I say h of the inverse at x is equal to 8, it is equal to h prime, or the derivative at x is equal to 4. And then this is going to just be square root of 8 minus a. It is equal to, this gave me 8a, if I remember very well. And then what I need to do, I need to square both sides, so as to remove the square root. When I do that, I have 8 divided by a, it is equal to 8 squared, it is 64a squared. So 64a squared, and then 8 is going to be 64a squared multiplied by 8 is 64a cubed. And then I'm going to divide by 64 by 64, and then we're going to have 8 is equal to, a cubed rather is going to be equal to 8 divided by 16 by 64, which is 1 divided by 8. And then when you cube root both sides, you'll get that 8 is equal to 1 divided by 2. So this question was not that bad, guys. This question was not that bad at all. It just wanted you to relax. You just needed to do what? To relax. Finding this, and then outputting that, and then finding the inverse at 8. So these were the critical things there for you to get your marks. All right. Now let's move to question 9. The graph of function f of x is equal to -2x cubed plus ax squared plus bx plus c is sketched. So we are having a cubic function, and now we are given the following properties. The first point is that point A is a stationary point. Point A with coordinate 1 and 0. This is a stationary point. But can you see that it is a stationary point and also an x-intercept? It is a stationary point and also an x-intercept. And I know that if one factor, an intercept or an abscissa that they used, if one factor, it acts as a turning point. Okay, let me write this. If a factor acts as a turning point and x-intercept, therefore we need to do whatever that factor is squared. So the factor that we have here, it is 1. So the factor that we might have, it is 1. So x minus 1 squared is going to be a factor of our cubic function. So we already have our factor, and it should be squared. Why should it be squared? Because now it repeats itself twice as a turning point as well as a stationary, turning point as well as what? X-intercept. By the way, stationary point is the same as turning point. Why are we referring turning point as a stationary point? Because our gradient is not increasing or decreasing. B with those coordinates is an x-intercept, so we have another x-intercept. So we have another x-intercept. X minus 4, if this is positive 4, it means this is going to be x minus 4 is a factor. Okay, so we have now two factors and they are enough. Because remember, for you to find the cubic function, you do this. If you have three different x-intercept, or you use this squared, if you have two different x-intercept plus one of them, one acting as the turning point. And then you have this one, y is equal to a into x minus p cubed plus q. If you have one x-intercept. This is when you have a graph like this. Okay, let me output each and every formula with its formula that you use. This, if you have this different x-intercepts, this one, we have two, one acting as a turning point, and then this one, you just have one, like that. Okay, I hope it makes sense. And then, by the way, these are the factors that we have for this function. And then point P is a point of inflection. Point P is a point of inflection. And remember, a point of inflection, it is a midpoint. Midpoint of the turning point. It is the midpoint of our turning points. And then point C is the turning point. That one we know. Point D is the y-intercept. Y-intercept, it is the value here that we have here. Here. So in this case, it is C. We are not given. So let's now focus on 9.1 on question without analyzing further. Show that 8 is equal to 12, B is equal to negative 18, and then C is equal to 18. On this part. So we need to show that A is that, B is that, B is that. So what, first thing first, remember, among these three formulas that I have, I need to use one of them. But which one is that? It is this one, the second one. Why the second one? Because why? Because now I have a factor acting as a turning point as well as an x-intercept as well as one factor acting normally. Okay, so I'm going to use that one. So I'm going to say, all right. So I'm going to say y is equal to a into x minus x1. Okay, let me square that. X minus x2. And then, guys, we just become mathematicians and we solve beautifully. Okay? We just become mathematicians and we solve beautifully. By the way, we know what is the value of a. Okay, this a, I'm not referring to the a here. I'm referring to this a here. Ax cubed plus bx squared plus cx plus d. I'm referring to this a here. So the a is negative 2. Okay, so I can substitute a is negative 2. And then x, the factor that repeats itself, it is which one? This one, x minus 1. So it is the one that repeats itself twice. And then the other factor, it is just minus 4. And then it's just a matter of me being a mathematical gymnastic. So I'm going to say y is equal to negative. So I'm going to start with this one first. X squared minus 2x minus 1 plus 1, sorry. And then x minus 4. And then I'm going to have negative 2. And then I'm going to multiply this one, the two brackets. Okay, when I multiply the two brackets, you can simplify this however you want, guys. But now I'm going to simplify this. So it's going to give me x cubed, x squared multiply. So I'm going to multiply this with the first x. So it's going to be x cubed minus 2x squared plus x. And then I now consider the 4 is going to be negative 4x squared plus 8x minus 4. And then let's just simplify negative 2x cubed. Or by the way, let's start collecting the like terms. Negative x squared, negative 2x squared minus 4x squared, negative 6x squared. X plus 8x, it is 9x minus 4. And then now y, it is equal to negative 2x cubed plus 12x squared minus 18x plus 8. Therefore, the value of a that they were talking about, it is 12. The value of b that they were talking about, it is negative 18. And the value of c that they were talking about, it is 8. So everything is fine and beautiful. Good. Then we have Kusal here. Kusal states that, okay, Kusal states that, okay, I think we dealt with Kusal before. On let me see if I'm being honest. We dealt with Kusal on function on what is this? This part. Or this one was Kasala. Oh, okay. Okay. So Kusal states that the tangent to the curve of f can be drawn through points C and D. Okay, validate the statement using appropriate calculation. So let's see if indeed the tangent passes through points C and D. Okay. Okay, the statement is that we have a tangent that passes through C and D. So how can we validate this statement? Okay, by the way, we already know the coordinates of D. D is the y-intercept, and then we know D is just C. So this is just 8. This is going to be a tangent. We can validate that this is a tangent only and only if you can prove that the y-coordinate of C is equal to 8. If the y-coordinate of C is equal to the 8, then it means that tangent passes through that one. Okay, passes through those points D and C. Okay, yes. But if y is not equal to 8, then does not pass. But if it is equal to 8, it does. Let's now try to be mathematicians. So let me see if so basically let me try to find the value of x. Okay, the y-coordinate of C. Let us try to find the y-coordinate of C. How can I do that? Remember, first thing first, D has the coordinate of 0 and 8, by the way, because it is a y-intercept. So for me to find the coordinate of C, I need to find, because it is the turning point, I need to find the first derivative and equate it to 0. Because I know the first derivative at the turning point is equal to 0. And then remember, if I have my equation as negative 2x cubed plus 12x squared minus 18x plus 8, the derivative is going to now be negative 6x squared plus 24x, plus minus 18. Then I can now divide by negative 6, by the way. So when I divide everything by negative 6, I'll have x squared minus 4x plus 3. And then I'll have x minus 3, x minus 1. And then x is equal to 3 or x is equal to 1. But I already know that x is equal to 1 is going to result to y being 0, because remember this act as a turning point and y-intercept. So I'm interested in f it is equal to 3. Let's look at f when x is equal to 3. So it's going to be, when I substitute to my equation, negative 2, 3 cubed plus 12, 3 squared minus 18, 3 plus 8. Then this gives me 8. So if this is equal to 8, remember I said if it is indeed equal to 8, then it means that tangent passes through D and C. Okay, therefore, tangent passes through point C and D. Okay, fine now. Point APB are joined to form triangle APB. Calculate the area of APB. 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 Let us remove now this mess. Let us remove now this mess. APB. Quickly remove. Quickly remove. APB. Now APB forms a nice triangle. Look. Okay, and then okay, I have APB forming a triangle. Okay, just remember this is just P. It is hidden there, but it is P. So how can I find the triangle of this thing now? How can I find the triangle of this thing? Now let us consider the triangle that we have. We're having a triangle of this some sort. And this, okay, let me do, this is the straight line here. Right. Okay, so we know that this is A with coordinates 1 and 0. This is B with coordinates 4 and 0. And then let's just remember this is the x-axis. And then this is coordinate P with unknown coordinates. Then it means we need to find those coordinates. Let me take this to where I'm going to now calculate. All right. So let me take my thingy there off to where I'm going to calculate and see if, okay, Vanna. Oh, my Lord. Okay, actually, I needed to copy this. Why am I acting foolish or dumb? Because I have a copy button. So let's have our copied extraction here. Okay, so now the question is, how can I find the area? Well, there are ways in which you can find the area. Okay, there are various ways in which you can find the area. The first one, it is maybe, okay, the first one, it is area is equal to half BH, but the H should be perpendicular. So can I construct any perpendicular H? Yes. I can form a perpendicular H here. And say this is perpendicular. Oh, okay. So if this I'm going to refer to it as my perpendicular H, then where my perpendicular H touches, this one should be my base. Okay. So basically AB should be my base. All right, let me say my base is going to be equal to AB. And now can I find the distance AB? Well, distance AB is very easy to find because it's just a horizontal length. For a horizontal length, I say x right minus x left. So AB is equal to x right minus x left, which is 4 minus 1. And then it is just 3 units. And this is going to be my base. My height is going to be, this is just a vertical length. For vertical length, I need to say y top minus y bottom. But I do not know the y here at whatever that point that I do not know. The y is 0. I may not know the a, but I know that y is 0, and then I need to find the y of p, but p is not my point of inflection. So it's easy to find the coordinate of point of inflection because remember this has a coordinate of 3 and 8. So, and remember what did I say? I said P is the midpoint of the turning point. So for me to find P, I need to use midpoint formula. You can use midpoint formula or the second derivative is equal to 0. It's up to you. So P is going to be equal to the x coordinate of the first turning point. It is x coordinate is 0 plus 3 0 plus 3. Okay, so not 0, 1 plus 3 divided by 2. And then the y is going to be 0 plus 8 divided by 2. And then the coordinates of P are going to be 1 plus 3, it is 4. 4 divided by 2, it is 2. And then 0 plus 8, it is 8 divided by 2, it is 4. So the coordinates of P are 2 and 4. So how can I find the height? My perpendicular height is going to be y top minus y bottom. Y top, it is 4, minus y bottom, it is 0. So it is just 4 units. And then can I output my area? Yes. Area, it is equal to half. What is my base? My base, it is 3 units. What is my height? Perpendicular height, to be more specific, it is 4. And then my area thereof, it is something like 4 times 3, it is 12 times half, 6 units squared. Okay? Yes, guys. I hope it makes sense. I hope it does. I hope it does, guys, make sense. For which values of f is for which values of x is f concave down? Okay, I know I need to locate my point of inflection. Concave down, it is here. Concave down, it is there. So I need to say x, because it is on that side, needs to be greater than the x coordinate of my point of inflection. It is 2. So this is my answer. So x is greater than 2. This was just an easy marks. Okay. And then for which, write down the values of x for which f is strictly increasing. Strictly increasing. Strictly increasing. Where is f strictly increasing? Where is f strictly increasing? I can now remove this. I'm done with it. Where is f strictly increasing? But f is strictly increasing from this portion to that portion. But the word strictly, they tell you that you need to exclude the points where it is not increasing. Remember here, it is not increasing or decreasing, it is stationary here. So it is strictly increasing between x is equal to 1 and x is equal to 3. So x needs to be between 1 and 3. Why am I not including 1? Because at 1, at x it is equal to 1 and x it is equal to 3, f is not increasing. It is stationary. Okay, so remember what do we mean? It means the first derivative, it is equal to 0. At x, it is equal to 1 and 3. Okay, but between 1 and 3, the derivative, the gradient, it is 1. Can you see now it has a positive gradient? So the gradient is positive. It's greater than 0. So it is between 1 and 3. Between x should be between 1 and 3, or someone might say x is an element of 1 and 3 being excluded. Now, this question can be asked, so an examiner can say, write down the values of x for which the derivative of a function at x is equal to 0. So f prime of x is equal to 0 means the gradient is greater than 0. And the gradient is greater than 0 when what? When your function is increasing. Similarly, f increases. Similarly, if the examiner can say where the first derivative is less than 0, it means it is where your gradient is less than 0, it is like this. So it means f is decreasing. Write down the coordinates of the turning point of h of x is equal to f of x minus 3. So what we see here is that our graph is shifted 3 units downwards. So if my graph of f is shifted 3 units downwards, whatever coordinates that I have, the coordinate that are going to change are the y coordinate because the x is not shifted. If I have my graph like this and it is shifted downwards, it's going to shift like this. So the coordinates here, whatever, let's say the coordinate it is a and b. The coordinate will now be what? A, b minus 3. So now let's consider our turning point. Our turning point where x, let's say f of x. The turning points of f of x were 1 and 0 and 3 and 8. But now, of h of x, those of h of x, since well h of x is just translating this one down 3 units downwards, so it's gonna be those of h of x is gonna be 1, but now 0 is gonna move 3 units downwards, it's gonna be minus 3, and then 3, and then this 8 is gonna move 3 units downwards, it's gonna just end up being 5. So this is how we find them. Stop being mathematicians, guys. Stop doing that. Just understand what is being required of you. Okay, the formula is, you can say the formula for turning point, it is x, y minus 3, because what we are affecting it is the value of y. Hey, let's move to question 9. Oh, sorry, question 10. Question 10. Okay. What does question 10 say to us? Let's see. Oh, sorry about that. What did I do? My screen. Let me do this. Now let's go. Let's look at question 10. This is the optimization type of question. All right. It was an interesting one, by the way. You need to be very, very careful in what you do here. I'm going to be slow, but not too slow. A metal box without a top, okay, is to be constructed. All right. From a what? From a square metal sheet with sides 20 centimeters. Okay. By doing what? By cutting square pieces of equal size from corners of the sheet and then folding up the sides. Okay. Before we go to a statement of what they are requiring of us, let's now have that box they are talking about. Okay. It's not that straight. Let us have a straight box. Much better. But now they are telling us that the box has dimensions. Oh, sorry, the square metal sheet, no, has dimensions of 20 centimeters. And remember, the lengths are equal, like for a for a square. But now we are told that it is being cut. Okay, they cut this square metal sheet that we have here at the corners. Okay, they cut it at the corners and they cut it into square pieces of equal size. So they cut it beautifully. Okay, into square pieces. They cut it beautifully into square pieces of equal dimension, of equal size. But we do not know that size. So let's just say the size is x. The size of all it is x. So it means this is going to be x, this is going to be x, this is going to be x, because it is a square. Okay. Now, if they cut this, this is going to result to something that looks like this. You're going to have box like this, where now there are some portion that has been cut. Excuse me for my bad drawing there. So this is what happens. We have removed now those square what they're off. We have removed them. Okay, we have removed them. But now it means now when we remove this, remember they have the dimension of x. This part has the dimension of x. Okay, if it has the dimension of x and this has the dimension of x, this has the dimension of x, when I remove those x and x, so do you agree that it's going to be 20 minus x, which is 20 minus 2x, not x squared, but minus 2x. So it means each and every dimension is going to be 20 minus 2x. Okay, but still considering this dimension, this dimension is still going to be x. This one, by the way, because when they cut it, they just remove these. again, but this dimension here, it's still x. Okay, I hope it makes sense. That dimension here, it is still x. This one, this dimension here is still x. Also, this dimension is still x. But now they're trying to they're trying to create a box. So when they try to create a box, it means now we should have a surface that lies like that. This will be our base. Okay? This will be our base. Now try to imagine us folding these parts. We are trying to fold these sides. Okay? We are gonna fold these sides. Excuse me for my my dimensions not being necessarily equal thereof. So just imagine yourself now folding those sides. Okay, when you fold those sides, what's going to happen is that you're going to end up having a box that is sitting again. And when you fold the sides, remember this dimension here, still x. It means this is also x. And now I want you to imagine taking this part and making it to stand, or just folding it. Do you agree when you fold it, it's going to create something like this? It's going to be something like so. I'm not sure how to draw this in 3 dimension, but it's going to stand in such a way. Let me see if it's like this. If I try to make it stand, like that maybe, I can try to make it stand like this. So when I try to make it stand, this portion here, it will be my height, because when I fold it, try to fold it in that direction. So when I fold it in that direction, just put your hand straight. Okay, just put your hand like this, flat, and then try to rotate it like this in this direction. When you try to rotate it like this, and let's say this dimension, it is x. This dimension where your fingers are at, it is x. Okay, let me try to open my camera so that this is clear. Okay, let me try to open my camera so that this is clear. Okay. Put your hand like this, okay? When you put your hand like that, it is that dimension, and this is x, okay? When this is x, try to fold it like this, such that it stands. Okay, we're trying to fold. When we're trying to fold it, do you see that my x is now is no longer the base or the length here? It will now become my what? It will now become my height. Okay, so this is what I want you to be caution of. This is what I want you to be caution of. Okay, we can now remove you. So this will now become my height. The x will become my height. So when I construct my box, there, still remember the typical way in which we construct a box. And then I'm going to have another part of the box here. Okay, let me try to join the box. Okay. So this is the base. Remember my base, it is this one, the one lying flat. And I already know that my length of the folded part, this part, it has the length of how much? Remember, this and this are equal. So it's just going to be 20 minus 2x. So it has the base of 20 minus 2x. Okay. Dimension of 20 minus 2x by 20 minus 2x, because this one, it is also 20 minus 2x. So also this side. It is 20 minus 2x. So it is a 20 minus 2x by 20 minus 2x box. And then what is going to be my height? Remember I said when you point your fingers like this, when you now rotate your fingers, this will become your x. Okay. So we have the length to be 20 minus 2x, the width to be 20 minus 2x, and then my height to be x. So now that we have analyzed this, let's now look at what the question is requiring us. Calculate the dimensions of the box which are largest with the largest volume that can be constructed in this manner. Calculate the dimension of the box with the largest volume that can be constructed in this manner. So remember, the largest volume simply means such that we have the maximum volume. Let me remove this part. How do we have a maximum volume? I'm going to have the maximum volume. Remember, okay, when we hear the word maximum or minimum in calculus, remember optimization is also calculus. Okay, it's just a continuation of it, again, application of calculus. So the maximum or minimum, you need to think of the turning points. Okay, so now let's have volume. Let's have a formula for volume first. So we have a formula for volume. This is just a square. Okay, this is just a box. Okay, a box will have, remember what is a volume? A general formula for a volume, it is area of the base multiplied by height. So for each and every shape that you have, if they want the volume, it will always be area of the, let me show you. It will always be the area of the base. Your base, it is a circle in this case. So a circle has an area of pi r squared, and then it's going to be your height here. Height. All right. So in this case, we are not having a cylinder. We are having a what? This box. So the area of the box is going to be what? 20 multiplied by 20. 20 minus 2x multiplied by 20 minus 2x. And you can agree with me that this is 20 minus 2x squared. And then multiply by height. My height, it is what? X. Agreed. I want to believe people are agreeing with me. So this can be expressed as volume is equal to, express this one, this is 400 minus 20 times negative 2 minus this, it is minus 80x. And then x squared, or sorry, x, then plus 4x squared. And then I still multiply by x. Therefore, my volume formula, now this is volume with respect to x, by the way. My volume formula with respect to a variable x is going to be, I'm going to start with the higher degree. 4x squared multiplied by x, it is 4x cubed minus 80x squared plus 100x. And then what do I need to do? What do I need to do? Now that I have a formula of this one, can you see this is a cubic function where a is greater than 0? Remember, a cubic function where a is greater than 0, the last shape, it is shape, it is something of some sort. For me to find the maximum value is at the turning point. I know the maximum value, it is at the turning point. And at the turning point, what do I know? The first derivative, it is equal to 0. So I will say, okay, in this case, instead of saying f prime of x, this is going to be a volume prime of x needs to be equal to 0 for me to find the maximum. Also for the minimum, it is still the same. Okay. So what is the derivative of my volume with respect to x? It's going to be 12x cubed, not cubed, rather squared, minus 160x plus 100 equal to 0. And then let me take out 4 as a common factor. Divide by 4, because it is a common factor. When I divide by 4, I have 3x squared minus 40x plus 100. Okay, plus 100 equal to 0. And then the factors of 300 such that when it is taken this. So it's going to be 3x minus 10 and x minus 10. And then now this will be a minimum value, by the way. Okay, so can we see that in this function thereof, the x coordinate of the maximum value should be less than the x coordinate of the minimum value. Why are you saying that? The x coordinate here, it is less than the x coordinate there. So the one that is going to result to y maximum, it is the x. Okay, it's fine. I'm going to come to that. Let's find these ones. X it is equal to 10 divided by 3, or x it is equal to 10. Between these two, which one produces the x value? Between these two, which one produces the maximum volume? So the one that produces the maximum volume, it should be 10.33, because This is the same or approximately 3.3333. So it should be here 3.3333, whereas this is here is 10. And but when x is 10, it results to a minimum value, minimum volume. But when x is equal to 3.333, it results to a maximum. So I need to say the dimension needs to be 10 centimeter. Okay, the dimension need to be 10 divided by 3 centimeter. Okay, I need to select that. Then, but they wanted what? They wanted the dimension. So the dimension, it should be, remember, it should be length times breadth times height. So it should be x, okay, I can say 10 divided by 3 centimeter by, my breadth is going to be 20 multiplied by, this is going to be 20 minus 2 into 10 divided by 3. This will be, when I do mathematics, 40 divided by 3. So by 40 divided by 3 centimeters by 40 divided by 3 centimeters. Or you can just say dimensions, the height, it is going to be equal to 10 divided by 3 centimeters. And then the base, which is equal to the length, is going to be 40 divided by 3 centimeters. I want to believe this question was now beautifully made. So these are the dimensions. But instead of saying the dimensions, they can say to you, determine the value of x, determine the largest volume. They can say calculate the largest volume that can be constructed. Okay, so when they say the largest volume, you will now substitute x is equal to 10 divided by 3 to your what? To your formula of Vx. And then you'll see that it becomes your maximum. Oh, this question was beautiful. Let's move on. Question 11. Okay, a six-sided die, okay, a dice name is rolled, and the number of dots landing face up is noted. Okay, remember a die has one number here and numbers on all six sides of them. Okay, and then on event A, the number observed is 2 at the most. Okay, so consider the following events. The event A, the numbers observed, it is 2 at most. So they observed 2 numbers at most. At most is that at maximum. The maximum numbers that they observed were 2. So it means the probability of A, it was just 2 numbers out of possible 6 numbers. Remember, a die has 6 numbers. So it is like that. And event B, the numbers that landed face up is an even number. Remember, when I have 1, 2, 3, 4, 5, 6, an even number. What is an even number? An even number, it is 2, 4, and 6. Okay, 2, 4, and 6. Those are what? Those are what? Sorry about that. Those are even numbers. Remember even numbers? How do I know even numbers? I was always struggling with even and odd. But now I check, even has 4 letters, and then this has 3 letters. So it means even about 2, 4, 6, odd it is about 1, 3, 5. Okay? Yes. And then it means now the probability that it will be an even number, which is probability of B, it is 3 possibilities out of possible 6. And then even see the number 6 is facing up. So there is one number 6. There is one number, which is 6 out of possible other numbers for 1, for 10, for 15. And then 1.1.11.11 determine separately the probability of A and B. Oh, but now I've already done that. Probability of A is going to be what? We have 2 at most out of possible 6, which is just 1/3. And then probability of B, it is of having an even number, which is 3 out of possible 6, which is just 1 divided by 2. So this is probability of A and B in simple version. Use probability of A and determine probability of not A. This is the same as probability of not A. Okay, still the same thing. So how do I find probability of not A? Probability of not A is equal to 1 minus probability of A. 1 minus probability of A. Okay, so it's going to be 1 minus probability of A, it was 1 divided by 3. So the probability of not A, it is just 2 divided by 3. Okay, not A. All right. Are the events mutually exclusive? Which events are you talking about? Okay, so are the events mutually exclusive? Remember, events are mutually exclusive when what? We say events are mutually exclusive when probability of A and B, but in this case, you have 3 events, probability of A and B, and I'm going to just add C is equal to 0. Okay? If the probability of A and B and C is equal to 0. Remember, when we have 2 events, we are saying when probability of A and B it is equal to 0, then these events are mutually exclusive. But if we are having 3, the probability of A, B, and C, you can say A, B, and C, or whatever, it is equal to 0. So we need to prove, are they equal to 0 now? I'm going to put a question mark on top of the equal sign. Okay, now, unlike when we have 2 events where I'll say, let me use the probability of A or B is equal to probability of A plus probability of B minus probability of A or B. I'll say, okay, let me check what do we have on A. Okay, on A we have 2 events. Okay, the number observed is 2 at most. So not the numbers that are observed. The number that is observed, it is 2 at most. So it means the numbers that are observed here, it is 1 and 2. So for A, we have 1 and 2. These are the numbers. I'm talking about the numbers. No, I'm no longer talking about the probabilities. For B, the numbers that I have, okay, that are even, it is 2, 4, 6. These are the numbers that are even. And then for C, it is just a number, 6. But now, is there no intersection between any of these? For it to be mutually exclusive, it means there is no number that should repeat here. But we see that 6 and 6 repeat between B and C, and 2 and 2 repeat between A and C, and so A and B. Therefore, no, they are not mutually exclusive. Why? Because probability of A, B, and C is not equal to 0. Because you can see clearly there is an intersection. So it is something like this. If I'm correct, it is something like this. The intersection between A, B, and C. So between A and B, it is 2, and then this will just A will just be A, and then on B will just be 4, and then 6, it is shared like that. So this is what we have. So can you see? For the fact that we still have the end part, the intersection part, therefore it is now in mutually exclusive. It is not mutually exclusive, sorry. Okay. Calculate the probability of A or C, okay? I know that the probability of A or C, it is just probability of A plus the probability of B minus the minus the probability of A and C. So what is the probability of A or C is what I'm looking for. Probability of A, what is the probability of A, Hannah? We still remember the probability of A, it is 1/3. Okay, the probability of A, it is 1/3. And then plus the probability of C, 1/6, minus what is the probability of A and C? Probability of A and C. A and C do not have a direct link. Can you see between A and C? There's no number that matches between A and C. So there's no, we can see here, there's no relationship between A and C. It's just A and B or B and C. So the probability is going to be 0. And then we're going to have a number that is 4 divided by 6, which is 2/3. Or half. No, just half. Because this is, when I multiply this by 2, it's going to be 3. Okay. So the answer is just half. All right. So yes, guys. Yes. Or the other way that you can do, you can say, or you can say probability of A or C, it is now the number of sample that A or C occurs divided by number of sample size. Okay, A or C, the events that between A and C, the events that we have between A and C, they are or rather the numbers between A and C, it is 1, 2, 3. Okay, it is 1, 2, 4. So there are three numbers. So it means now there are three numbers. Out of possible all numbers, it is three, which is just half. But preferably, I'd prefer you to use this and not do mistakes. Are B and C independent? We need to make use of this statement. What are independent? What do we mean that events are independent? The events are independent if probability of A and C it is equal to probability of A multiplied by probability of C. But now the question is, are they independent now? We need to prove. When you prove, you do not start with this statement. When you prove, you start with the left-hand side and then come with the right-hand side. Let's prove left-hand side. Actually, let's find probability of A and C. Guys, we just say the probability of A and C, it is 0. Okay. We just say the probability of, B and C, sorry, B and C. Probability of B and C, we still remember the probability of B and C, it is 1. Okay? The probability of B and C, it is 1. Because they share only one number. So it is one number that they share out of possible 6. Okay? They share one number out of possible 6. And then let's look at the probability of B multiplied by probability of C. If it gives us the same thing now. I don't need to limit myself to space. I have enough space. The probability of B multiplied by probability of C, it is how much? Let's see. Probability of B, still remember the probability of B? It was 1 over 2. Probability of C, you still remember that? Probability of C was 1 over 6. So automatically I can see these events are not. This results to me having 1 divided by 12. Therefore, I'm going to say, therefore, probability of B and C is not equal to the probability of B multiplied by the probability of C. Therefore, B and C are not independent. Independent events. Or you can say B and C are dependent events, but preferably we use independent. Okay. Another notation for and, guys, you can say probability of B and C, or probability of B and C, or probability of B or C. In case in final they catch you, it's going to be probability of B or C. How I don't normally know this is that for and, it has the middle end like that. So it means it's going to be this. I'm moving, guys. I'm done. 11.2. 11.2, interesting question. The probability of getting the first answer in a quiz correct is 0.6. Okay? So, the first answer, the probability of getting the first answer correct is 0.6. And then if the first answer is correct, the probability of getting the next answer correct rises to 0.7. If the first answer is correct. However, if the first answer is incorrect, the probability of getting the next answer is 0.4. Write down, okay, with the use of a tree diagram, determine the probability of getting the second answer correct. Okay, let's now first find the Venn diagram. Let's use, not Venn diagram, sorry, tree diagram. Okay, it's clear that it's either, in a quiz, it's either you get it correct or wrong. Okay, where C is correct, where W means wrong or incorrect. You can use alternatively incorrect, but you need to indicate that it is incorrect. So they are saying the probability of getting the first answer in the quiz correct is 0.6. So first attempt that it is correct, you get it correct, it is 0.6. So remember the sample space, or now the probability, should add up to 100%, or 1, or or 1. Okay, 1. So if you get it correct, the chances of getting it correct, it is 0.6. What are the chances of getting it incorrect? It is 1 minus 0.6, which is 0.4. They won't tell you that, but you need to be aware of that. But now we know that getting the first one correct does not mean automatically the second one you're going to get it correct. We need to see. It's either, after finding the first one correct, it's either you get it correct or you get it wrong for the second attempt. Okay? Now they tell you that if the first answer is correct, the probability of getting the next answer correct, it is 0.7. If you get the first answer correct, the probability of getting the second answer correct, it is 0.7. So if you, for the second attempt, you get it correct, the probability of getting it wrong, it is 0.3. Okay? And then if they say if the first answer is incorrect, meaning if the first answer is wrong, the probability of getting the next answer correct, it is 0.4. If the first one was wrong and the second one is going to be correct, the probability of getting the second one correct while the first one was wrong, it is 0.4. So I know if getting it correct for the second time while the first one was wrong is 0.4, it means getting it wrong again for the second time, it is 0.6. Okay? And then, okay, they did not say we should do this, but this is you getting correct. Okay? This is correct, wrong. Correct, wrong, or wrong. Okay, not wrong like this. Wrong, correct. This is wrong. Okay? So now, let's answer the question. The question says, with the use of a tree diagram, determine the probability of getting the second answer correct. The probability of getting the second answer correct, irrespective of whether the first one was wrong or correct. So the probability of getting the first one correct is going to be whether the first one was correct and the second one is correct, or the first one was wrong, the second one was correct. What's important is that it is what? The second one is correct. So it's going to be the probability of, let me say, the probability of getting the second one correct, it is equal to the probability of getting the first one correct and the second one correct, plus the probability of getting the first one wrong and the second one correct. So what's important is that the second one, it is correct. And then, what is the probability of correct? Probability of correct, it is 0.6 multiplied by 0.7, by the way. So it's going to be 0.6 multiplied by 0.7, because correct, it is this and this. Okay? And then getting the first one wrong, but the second one correct. Getting the first one wrong, but the second one correct, it is 0.4, 0.4. 0.4 multiplied by 0.4. And then when I do mathematics, it is 0.42 plus 0.16, which is now mathematically beautiful to be 0.58. So there are high chances of getting the quiz correct in this particular manner thereof. So yes, guys, this is how we were going to move about that one. Okay. So the last question is, by the way, it was removed. Okay. It was removed, but I'm going to attempt it. The discus cage on an athletic field must be moved to a different position. Then 5 boys from group of 15 boys must be selected to perform this task. Okay. And then how many different groups of 5 boys can be selected? Okay, so we have 15 what? 15 groups, okay? 15 groups of different boys. Okay, actually, let me say we have 15 groups. And on those groups, I need one boy. I hear one boy. And now they are not saying that you should take one boy from each group. You can take 5 boys from one group. Okay. So you need to take note of that. So I need 5 boys. But how many groups do I have? I have 15 groups. But I need 5 boys. So I can now take from the first one, okay, from the first group. Okay, let me say, for me to take a boy, okay, for me to take the first boy, I have 15 options. I have 15 groups to take the boy from. And then after taking one boy, I'm left with 14 groups to choose from. Again, I'm left with 14 groups to choose from. And then I remove that group that I have taken from, and then I'm now left with 13 groups to choose from. And then I remove the group, I'm left with 12 groups to choose from, and then I'm now left with 11 groups. Okay, so this forms the first boy, the second boy, the third boy, the fourth boy, and now the fifth boy. Okay, so I have that. So the probability of choosing randomly those boys, it is 15 times 14 times 13 times 12 times 11, which is now 360, 360. But these boys can be arranged, okay? These boys can be arranged in 5 possible ways, okay? These boys can be arranged in 5 factorial ways. So now, it means now the number of sample, okay? Basically, the probability of choosing, okay, boy. Remember, it's not limited from one group, and there are 5 ways in which I can arrange these boys. So I need to have 5 factorial because these boys can be chosen in any order, okay? In any order. So I need to consider that there are 5 boys that can be arranged in anyhow, 5 factorial ways. So it means now how many different groups of 5 boys can be selected. So different groups, okay? Different groups is going to be the total that I can choose from, divide by now the boys that I have. Okay. This is the probability of choosing from the 15, from all the 15. Okay. This is the number of chance, or rather of the number of chance, yes, let me say the number of chance of getting one boy from these 15 groups, 5 boys from these 15 groups, okay? And then we need to divide by those 5 boys that can be arranged in any way. The reason I'm not dividing by only 5, it is because these boys can be arranged in anyhow. Okay, first boy, second boy, third boy, fourth boy, the fifth boy, and I know these boys in this manner. This gives me 5 factorial. So let me see, 360 divide by 5 factorial. It gives me that the possible different groups, it is 303. So there are 303 groups. Okay, but remember this question was removed. Okay, question was removed during marking. Okay, the question was removed when they were marking, and then yeah, but okay, this is how one could have went about that one. The reason they removed this question is because many students couldn't attempt it; they left it unattempted. Okay, they want to believe it was now out of the scope because there is no way we have dealt with a scenario like this. Okay, yes. So thank you very much, guys, for being with me on this marking of a, or rather the memo of 2025 trial. I hope you enjoyed from the moment from question 1 up to the last question, and I hope you do not or you understood everything. If not, please leave it on the comment section and leave a question on, and I'll clarify whatever that you need clarity on. So thank you very much, folks. Until we meet again. Okay.